because I'm not.
Day 3. Welcome to day 3. Again, all recordings are available, so you can watch everything at your own pace. Thanks, Wim, James, Andrea, Ludovica, yesterday for the sessions. Did I miss anyone else? And they were very interactive sessions yesterday. It was very rich. Day 3, Friday, December 10. I'm already doing the recap. We did a lot of more technical things also yesterday, and we saw the semantic brand score in action. Today we have on the agenda brainstorming on the Envision data. But since we're now in this multimodal paradigm, I really hope that you see it more as much more than the mind storming or the brainstorming, more body storming and thing storming, everything we can use in terms of extended cognition and distributed cognition to make that session work would be beautiful. So that will be by Joaquim Santuber, my very dead colleague. Then we have a technical break at 11:15 to 11:20. We go on to Spacy for Envision. Particularly, it's a hands-on session where we see how text could also be processed, analyzed, but we could also pay a little bit more attention to the visual outlook, how Spacy is organized, and also take inspirations from there for what the Envision toolbox could be in the future. So that would be by Manoj and Professor Melo. Then we go for lunch break, 12:20 to 13 o'clock. And then we, at 1 o'clock to 14:30, we have data-driven versus theory-driven research by Professor Wolfgang Maass. I think he's dialing in on Zoom. So then we have a short coffee break, and then we go finally to the session by Daniel, Dominic Houghton. He's from Bielefeld. He would be giving a session hands-on on multi-sync pi.
He's just arriving.
Awesome. So we bumped into him yesterday in the train station, and I remember that the only thing I'd seen about him was the photo that I saw in the email. So I was like, I think I know this guy. And I showed him a photo of himself, and he was like, yeah, that's me. That's me. Okay, so I know he's around. So then we go at 16:15, 16:45 to research paper ideas. This will be in breakout rooms, ideally. But we also don't want to overstructure the life out of it that guys online and guys here cannot engage beautifully. So, and then we end with just more open reflections. Big heads up. I asked dogma specific questions yesterday to the speakers. I would also be asking each person for one dogma that they are looking to break in their field. So just a big heads up to you right now, so you have the whole day to prepare that. I thought I was a bit maybe unfair to the speakers yesterday, but I got away with it. So so that will happen, and we wrap up at 16:45 to 17 o'clock. What I now want to try, where's Wim?
He's greeting Daniel.
Okay. So please rise up. And online, I invite you to watch us, because I think the success of what you do after in this session will be dependent on how successful and engaged the people here are. So you can blame them if you don't get it right. What we want to do is a one-word story. So I start with once. Upon, yeah.
The time. One word.
A. Time. Yeah. Yeah.
There was a fish.
In.
We got an N over there, and then you're next. A huge.
Okay, let's stop. So you get that you need to get it, at, because we have an audience that's really trying to, yeah, be inspired by what we do. So we need to probably show our intentions more. Once.
Upon.
A. Time. There.
Was. A.
Which was your, what?
A.
There was a.
Any word.
Snake.
Okay.
In.
There was a what? I missed that. There was a what?
Snake.
Snake.
In.
The. Biggest.
City.
In.
The.
Country. Which. Was.
India.
One word.
Okay, I think we should end that round there. So I think you guys have a lot of work in your hands, and this is where it gets to be a really cool experiment, because now we want to learn from you how you would do a one-word story online. So I hope that you've picked from the group a bit of how gesture would signify intent, that I'm next. I thought I would see more from James saying, I'm next, like, or this, but so now we want to learn from you how you would do a one-word story online. So you can start, and we see how that goes. And the plan is that after you finish, we do it all together. So Alina, you can start.
We're gonna try to set up so everybody's desktop is the same when they look at it. That is, we can determine that.
You kind of.
Gallery. You want the
Sure
gallery
you can.
view?
Yeah, go to Ansicht.
Yeah, sorry. Yeah, I'm gonna.
It's the teacher's secret from remembering
Alright.
who's in the class.
Women's gone again.
Okay.
It works better with the camera, I guess.
So just to help you out, in case we did terribly wrong here and you got lost, if I did a one-word story with me, Joaquin, and Jonathan, you would see that maybe it's easier or more difficult. Once,
Upon.
A.
time.
There.
Was.
Two,
Girls.
Sitting.
on,
A.
Bench.
but,
They.
Sadly.
did,
Shoot.
Had.
the,
Bird.
Than.
killed,
Each.
One.
of,
The.
Figures.
Okay, so short term seems to work. Long crowd, football stadium size.
Well, part of it is we do this a lot and we're used to it. And one of the big secrets is my wife teaches this also. Some of you know Annie. You just say the next obvious thing, or you just say something, right? You just, and that's, well, anyway, go ahead.
Yeah. Anyway, so we'll see.
Shit.
Was that your first word?
Okay, so you started the story with all shit.
He doesn't know his own.
Gregor, we can hear you very well. We can hear you, Gregor. It's
So
all
let's
good.
do one word story with Gregor once.
He can
Oh, he can't hear
I
that.
think there's something going on. He can't hear.
All good. All
Oh, my
good.
connection.
Okay.
Okay.
Now, I think people might be wondering, did Baba and I call each other to say we're wearing this color? Probably.
Someone said something about the temporal synchrony on another scale.
It's amazing.
So Ying?
Yes.
Jing?
So shall I start?
Jing, yeah. You could start.
yeah.
You could start.
Okay, I will again go once.
In.
A.
Country.
Fair.
Was.
A.
Okay, so a good hint. We can start again, but signify your intent. So
Yeah,
that
maybe.
so that someone knows that, because half of the time you're thinking, what do I want to say? But who's going to talk next? I don't want to talk over someone. So Jakob, you can start once.
Today.
We.
Are.
Having.
Two.
Learn.
A lot.
Okay.
From. Beautiful.
New.
That's.
One last word from Julia. Beautiful.
That's a good word.
Beautiful
Techniques.
techniques. Okay. Yeah, let's listen. I hope you have your next research paper for trying to do that turn taking. Yeah. So please, I give the floor to my colleagues and enjoy the brainstorming session on Envision data.
Thank you, Baba. So we will be sharing a little bit because, wait, let me change the screen first. So you have many computers here. Yeah. We will be talking to you and telling you a little bit more about Envision data because we were also discussing just before the sessions today that it's an Envision Bootcamp, Envision data, and maybe some of you, I mean, I've seen the data. But maybe some of you are still like, okay, Envision is a beautiful word, but what is this data really? So that's where we want to what we want to disguise. I think that's correct. We want to show you this today. No, disguise is the opposite. Actually, we want to undisguise.
No, I want you to disguise it. But
Yeah, no. Yeah, so I think Joaquin is gonna start and then, yeah, we're gonna have a brainstorming session with you.
Gregory's back. Can anyone add him, please? Because I'm now here. Thank you, Ola. So yes, one of the purposes of the Envision Bootcamp was, of course, to bring different expertise together, different perspectives, to see how can we collaborate, how could we create together something new, and that could be by looking all of us at the same data set. And that's the Envision dataset that we have been working on. Jonathan, the first day, already introduced the dataset more in depth, but also could be beyond that. And in this session, together with Ola, we're going to moderate, we're going to facilitate a way that in which we all engage more and share what ideas for collaboration we could have, right? So basically, the starting or big frame idea would be, if we could work together in this data set, what would you do? And then what would you do? What would that mean? What could we learn? What could we understand from applying such method? So we'll go a little bit deeper into that, but first we're going to share with you the principles behind this proposal.
So some of the principles that we want to encourage is definitely doing open science and I mean, here we share the code with you. And that's basically, I think, the learning process also for us, for me, definitely, to start developing something. And like we were talking yesterday with Vim, it's like an Olympic torch or the Olympic light, and you just give it further to the next person. And I think that's something that we really want to do. Here, radical collaboration, or collaboration. So, and this actually, this misspelling comes to my next point. I'm a phonetician, I'm a linguist. And here, I work with designers. I know nothing about design, right? Barely anything. And this is something that this data allows us to do, like work with people that we might not have worked with before. And that's what we want to encourage, actually. So me as a linguist, I have a different approach than maybe Jonathan has or Joaquin. And this would be my radical collaboration with different fields and transdisciplinarity of the research. And if you want to find out more and cite the work that we have started here, you can find the information also on the Bootcamp GitHub page. Yeah, but let's maybe show the data.
Yes.
A little bit. Yeah.
Yes. Just for this data set, as Jonathan mentioned, was created a long time ago, and the rules in which this data set was created doesn't allow us to share it openly, to make it openly access. However, we're open, and it's possible to engage in collaboration with specific projects. So that's what we're looking for too. We could do that. But first, we would like to share with you just 2-minute long clip of one of our teams, Team 10. Yeah, please.
Don't record it.
Yeah, that's the point. Yeah, please don't record it. We're gonna stop. No, we won't stop the recording, but then we will cut it from the video that we will share because we're not allowed to. But in this context, but anyway, we want you to have a sense of what the data set look like, right? Because we have been talking about it. Wim, James, also the presentation, they share the code which they have been working on. So let's have a look at it. So you want to explain what you see here?
Oh yeah, okay. So actually, what I've been mostly concerned, because I've annotated this data, I've analyzed it before the bootcamp for Vim and James and all the wonderful presenters here. We've been mostly working with the top view data, and I think these are the snippets also that you might have seen, like this kind of setup. So what the people are doing, they were asked to redesign something, and they come from different fields, but like engineers, designers, and so on and so on. And there are always 3 people, and you see in the top there is always a camera that is facing each person, right? So we have this kind of front view, but we also have the top view, and it was really good for us with the hand tracking and looking at the gestures. And also we have some other data. We know the age of these people, who they are. We know their gender, right? So maybe if you have a maybe more sociolinguistic or socio-otheristic approach, this might be some interesting data for you. We also have different prompts or stimuli they've been working on. They all got like the very fine, detailed engineering sketch. Some got like, you see this here is like a cardboard thing, like a what's the name?
Experience-like model. It's a
model, yeah, a model, like a funny kind of cardboard model. Some got like really nice wood model. Some only got another sketch. So we have this additional data also about these people and different camera views that we can work with and analyze. Okay, no talking anymore from me. Huh?
There is a great blog over the 3 top views. This is something that we just did now to hide the faces, but the original recording doesn't have that, of course. So.
Yeah.
Ooh, and a glove.
Yeah, how about some like of a glove thing, because you want to touch a surface, right? You learn a lot by
Oh, yeah,
feeling
the
the
feeling it.
friction.
Yeah, it doesn't have to be visual.
You got multi-sensors for friction, for hardness, for
Right.
whatever, and then you got the big sensor that collects sort of optical data.
So what if you want to
You
touch?
just rub things.
What if you want to touch
it's like
things that are far away or
flash.
scary, right? Then you could have like a. Because I'm looking at this, I'm thinking if it's touching but like wireless, like you can throw it over there,
Okay,
like it's
yeah.
on a
Like,
string or a.
and that also gives you gesture.
Ooh, I
as
like
the
that.
control. Like you
Right.
go, like, give me that.
So
give me that.
what's cool is you can do a whole series of gestures. You can point,
Right.
and then you have a display. So this would be your display here. So let's say display is here.
Right.
Maybe a couple buttons, but then you have the different fingers. You can, I love the ability to touch or point, and then this is, you're using your finger gestures
Right.
to define functionality, which comes up on the display. So glove.
Bracelet.
I love that. Oh, bracelet's interesting.
Bracelet.
What if a
Here.
bracelet with
Yeah.
just a few
One-
connectors, so it doesn't have to be
yeah.
a whole glove.
Yeah,
Just
one sensor.
cool,
Touch
and
sensor
a little ring thing. So it then almost becomes a jewelry thing,
Right.
right? That you have this, put it on, and you're good to go.
What if you got a
Well, that would be
guy
the
that's like a-
competitor. So this would be the what's we need to name it. It has like material analyzer.
Material analyzer.
That's so sexy.
So what if you've got like a just a little thing like a jack, right? That you can just set down. You can put anywhere, and it's a little wireless thing. So it goes, and you get all of your data over here at the computer, right? It just all it does is exactly
Yeah.
just sends.
Or
and
even you have a whole pocket full of these
Yeah.
things. You just throw them in the room and it picks up everything.
It just picks up everything.
Yeah. And
Is
just,
that way you don't even have to go?
Oh, and then actually you do the thing they did in MIT. Those aren't little jacks. They're little cockroaches, right?
Ooh, and they look. Yeah, so you're seeing maybe like 5 frames per second, I think, but we're gonna try to maybe
And they just run around the like of a glove.
because the video is
Yeah.
ooh, and a glove.
Yeah, how about some like of a glove thing, because you want to touch a surface, right? You learn a lot by
Oh, yeah,
feeling
the
the
feeling it.
friction.
Yeah.
I have to stop sharing and then we share.
So we're gonna work on increasing the frame rate over Zoom because it's of course not the frame resolution is not optimal for analyzing gestures and thinking about. But you can also have a feeling what James was talking about turn taking. Like one says bracelet, oh bracelet, yeah, it's a good thing. And I have to tell you, we have one audio channel here, and it was a lot to kind of in Elan. I did this in Elan. I annotated the intervals where every person was speaking.
Oh, God.
Yes, so there is a lot of overlap. And sometimes the one guy starts singing, like doing like humming. And there's so much going on in this data. Yeah, maybe let's have a
give it a
try.
try now.
Yeah.
Ooh, and a glove.
Yeah, how about some like of a glove thing, because you want to touch a surface, right? You learn a lot by
Oh, yeah,
feeling
the
the
feeling it.
friction.
Yeah, it doesn't
nice,
have to be
nice,
visual.
nice.
You got multi-sensors for friction, for hardness, for
Right.
whatever, and then you got the big sensor that collects sort of optical data.
So what if you want to touch?
You just rub things.
What if you want to touch
it's like
things that are far away or
flash.
scary, right? Then you could have like a. Because I'm looking at this, I'm thinking if it's touching but like wireless, like you can throw it over there,
Okay,
like it's
yeah.
on a
Like,
string or a.
and that also gives you gesture.
Ooh, I
as
like
the control. Like you go, like, give me that.
So
give me that.
what's cool is you can do a whole series of gestures. You can point,
Right.
and then you have a display. So this would be your display here. So let's say display is here.
Right.
Maybe a couple buttons, but then you have the different fingers. You can, I love the ability to touch or point, and then this is, you're using your finger gestures
Right.
to define functionality, which comes up on the display. So glove.
Bracelet.
I love that. Oh, bracelet's interesting.
Bracelet.
What if a
Here.
bracelet with
Yeah.
just a few
One-
connectors, so it doesn't have to be
yeah.
a whole glove.
Yeah,
Just
one sensor.
cool,
Touch
and
sensor.
a little ring thing. So it then almost becomes a jewelry thing,
Right.
right? That you have this, put it on, and you're good to go.
What if you got a
Well, that
little
would be
guy
the
that's like a-
competitor. So this would be the we need to name it. It has like material analyzer.
Material analyzer.
That's so sexy.
So what if you've got like a
just a little thing like a jack, right? That you can just set down. You can put anywhere, and it's a little wireless thing. So it goes, and you get all of your data over here at the computer, right? It just all it does is just sends.
Or even you have a whole pocket full of these things. You just throw them in the room, and it picks up everything.
It just picks up everything.
Yeah, and just,
that way you don't even have to go.
Oh, and then actually you do the thing they did in MIT. Those aren't little jacks. They're little cockroaches, right?
Oh.
And they just run around the room
and basically let you know what's going
with
on.
antennae.
Yeah.
And a little sniffer, and they just run around the surfaces.
Right, and then so it all comes back to your.
What if they all?
Okay, so now I think you got like 10 frames.
Yeah.
Ooh, and a glove.
Which is slightly better than 5, but yeah. So you can see also what the why were we showing you all of these scripts, like with the hand space and stuff. Now maybe you can understand, because people are like showing each other in their hand space, like turning their hand. I don't know if you can see these online, but say my hand goes like this. But then I want to show you something which you're drawing, and I do like this. And I show this to you, so this is a weird hand. Like, why does this human have 3 hands, thinks the computer? So that's why we were doing all these kind of scripts to analyze this data. And for people like linguists like me, I think about prosodic modulations, that's so sexy. I love this. And I think, why is this guy doing this? Why at this point, right? People who work with disfluencies, right? In Bielefeld, Simon, our friend, works with disfluencies. There are like so many false starts there, so many disfluencies that were not even in the transcripts.
Can you say that word again?
Disfluencies.
Disfluencies.
Yeah, like.
I love that.
I love that. When I do like this or maybe like that. And these things we didn't have in the transcripts. Why? Because they're not normal speech. But we have them on the audio. So why not do something with that? And people were in a kind of natural environment for them. They were like, some were getting more into this, some less. But you see, maybe like, I would love to hear more of your background also. Sorry, I keep keeping this. So maybe Joaquin, you can,
Yes, thanks Ola for the background. I think Ola probably, together with Jonathan, those who know best all the little detail on that data set. So we're gonna do a very simple exercise, which consists in 2 steps. The first step is about using your imagination or trying to think a little bit differently, and we will simply ask ourselves, what if we use or do something on the Envision dataset? So how, if we apply a different methodology, a different theory, a different software, different kind of data analysis, that you think, we could do that. So what we're trying to do with this first step is to map different possibilities that we have from our research expertises into doing something or gaining a new perspective on the dataset. And the second part is making sense of that change, right? So, okay, what if we do this? Then what would that mean? That means that we could understand better synchrony. That means that we could learn more about disfluencies.
Disfluencies, yeah. Disfluencies.
We could publish a new data set. We could create a community. We could create, I don't know. You need to also help us in this sense making. And we're going to do it in 2 steps. Another 2 steps. So first, each one of you is going to do it alone or individually. What's your proposition? What's your proposal? And then we will share and we will exchange and discuss what could be done. What could be done? Yeah, Jed?
And please bring your point of view. I mean, I was just blown. I've been working with Ola for a while, and I'm blown away. She's talking about things I've never considered. And I'm so excited, like, wow, that's really cool. And also the theory that's behind it, right, that you're presenting in your speech and your point of view. So please bring your point of view. If you're a teacher, bring that. If you're a sociologist, bring that. If you're a gesture person, bring that. If you're et cetera, right? Whatever it is, because that's really transdisciplinary. And this is, I mean, I'm blown away. This is great, right? I'm just going, wow, look at that. So thank you.
Can we also ask some questions about the data sets? too?
Sure.
Yes. But for example, this particular way of, well, maybe we can do that later. That's right. Yeah. Whenever you have time.
Do you want to ask?
Yeah.
Come on.
Okay. So this particular way of talking, right? It's also very American, I think. If you have a bunch of Dutch people, there nothing much happening, right? It's not as peppy. It's not. Is every group like that, or is this a particular context where design people you need this peppiness to get at a certain creative smoothness? Or for me, it feels really unnatural. I would feel like I would go like.
Yes, of course.
This is just one point of view.
Yeah.
And I'll give you a couple of micro points of view on it. There has been a lot of research on affect and humor. One of the first talks I gave on this data set was design pornography, because these people are going, ooh, yeah, come on, yeah. That kind of thing. And so that's one thing. And there are lots of Americans who don't speak this way, and there's some engineers who don't speak this way, and there's some who do.
Yeah.
The other thing, and I think this is the most important thing, I gave a talk about this in another country, in another culture, and someone in the front row got up and started screaming at me, saying, this is fake, they know they're on camera, they're performing. And I said, well, yes, they are performing. There are 4 cameras in the room, they've signed releases, and they are performing.
Yeah.
And the whole notion is designing is a performance. Everything we do is a performance. Would we say that jazz musicians on stage, when they're performing, oh, it's fake, they're on stage, they're performing, they know they're in front of an audience? That's crazy. And the notion is that far from being unnatural or unnatural, there's a whole other class of performance. And we want to teach people, the athletes in a stadium know that they're performing? Yes. When they do their dance after they've made, a score, it's a performance. And so why not teach best performance practices? So those are 2 thoughts about this. Not everybody does it, but we want to copy the best people. So that's. Now, Ola, I think, and you have a thing to say about this. Anybody else?
Just a related question. So they are trained in how to respond to explanations and like suggestions and how to reject them and so on, right?
It's on.
Yeah, thanks. Yes and no. The big yes part is these people all have done a bunch of improv, so they understand that. They have not been trained in the formal methods that we've developed after looking at this data set, okay? So you'll notice that they build and build and build, and they're not looking for a final thing, right? They're not giving an idea. It's like, ooh, what if it were this? Oh, and it's all about implications and filling in those implications rather than reaching a type of static agreement about something. So it really is, so they are trained in it, but not in the formal ways that we're talking about having a basic training, right? And you'll notice other people, when they work, will do it, but probably not in quite such a big way. Sometimes it's just, let's make the buttons work better, and they can do that. And then there's some groups who just shut each other down every step of the way. And you'll see this in the data set. It's incredible. They'll find all sorts of reasons to say, no, not that because of this, or that's dumb, or nothing, right? So anyway, so yeah, yes and no. These guys are spectacular though. I mean, you're watching a great group.
And if just adding, so here we saw a snippet where there were 2 men and 1 woman. And the woman was slightly younger than the men. They cooperated really good. But there are groups that have only women. There are groups where there are only older men, and so on and so on. So we have all these kind of very heterogeneous groups. And we can also see cooperation from this kind of social perspective. We can look for social linguistic, maybe like convergence phenomena, convergence of gestures, convergence of speech. So, and how do they interact, right? The both convergence paradigms, so to say. That's why it's multimodal also. So we can look at different modalities, also maybe at the way they're drawing or the amount they're drawing, because they are all drawing or writing something. How engaged are they? How much time do they devote to talking, gesturing, and so on and so on? So the groups are very different, right? And this all can have influence. Even, you know, what we ate for breakfast can have influence for us. Very like phonetic experiments, very fine detail. But yeah, I think we have some really exceptional data here.
I want to add just about what they ate for breakfast kind of thing. We found out inadvertently by accident that very often what's on the wall in their kitchen or what they read has impacted what they say. Okay, because I happened to go to one of their houses and offices and looked at something on the wall afterwards and I went, oh my God, that's what they were talking about, right? So all these factors are very salient factors in terms of what's going on. It's a big picture in that way.
So we could go to the step where we'll ask you to engage with people here, also people online. I share with you via in the chat the link to the PowerPoint slide, and in the PowerPoint slide you're going to find many of this slide. How would you further explore the mission dataset? So just pick one of them and type in your comment and your notes, and maybe we can go back to the examples. I could provide one example that is from my own expertise. So I have a data set of video of court hearings, so recording of online trials of Chilean court. And I think it would be very interesting to analyze those videos too, and then perhaps compare them with the Envision data set. That is the what if part, and then how could I make sense of that? Then I could see how different, or I could make a comparison between the creative process or the analytical process of judges and lawyers in a court compared to a group of designers. Right? That's something that we can learn from looking at these two data sets. I know there are other examples. For example, already Andrea yesterday mentioned some idea of the SBS, the social brand score, together with gesture. What would that mean? So that would be the exercise to do for you, for example, and so on.
Well, I'm thinking about affect, what Andrea was talking about, if we could measure affect in that way as a brand. Something you mentioned before is these guys are so excited. Is that typical? Well, different teams have different affect brands, right?
Yeah, we talked about energy a lot, like the energy, and when we also compare it to other teams.
So please go, exactly, please go to the slide. The link is in the chat. Find one slide for you and type in the way. This is just a proposal. You can just write the way you want it, right? And then we will share it and we will discuss it. So let's spend 10 minutes.
In the chat?
There's a link in the chat for the
We need
presentation.
to write something down in the chat.
No, on
No,
the
the link is
PowerPoint.
the PowerPoint link.
Yeah, I know.
It's in the chat. Did you receive it?
Yeah, I received it.
And could you open it?
I'm opening it now.
Yeah, you cannot open it in the web browser. You don't need to have PowerPoint. We just switch it to PowerPoint. We thought it would be easier than Miro. So let's try it out. And then we will share.
Is it going online? Is it?
So, yeah, did everybody online get it?
Online participants, yes, we can see some hands. Alina, thank you. Gregor, yes, wonderful, okay.
And then you can
How
add
much
it to
time?
PowerPoint.
Yeah.
Oh, okay, you add it to
So,
PowerPoint. Okay.
Each one of you pick one slide. There are 20 slides or 30 slides like this. Pick one slide, enter your thought. If you want to put your name, put your name. If you don't want to put your name, also fine. If you want to create a fictitious name, even better.
You want to make up a new slide?
Or make up a new slide. You want to change it also, fine. It's just a proposal.
10 minutes, right?
10 minutes.
Okay, so the clock is ticking.
Ola, I thought,
Sorry, to me it says it is secured, so I cannot
you have to
write
give security to
something.
everybody. You have to give permissions to everybody.
It's
You have to
secure.
give permissions.
Yeah, it's secured.
I shared the
We are
one.
working on solving this problem.
It's so interesting, what you pointed out. We were so careful with those transcripts. I had it done by 2 different people, because the first one was shit, and the second one was a medical legal, I mean, a lot of money, but perfect, and then I checked them over. Except my framework for speech didn't include
Fluencies.
disfluencies. And I think, I'm thinking about disfluencies are actually part of normal speech, but not part of how we report speech.
Yeah, for sure.
Right?
It's like words that we don't normally write. Like, okay, in English we don't have, like, maybe, in English we don't have good words for that, but in German it's like, some words like, rappel, zappel.
Where can I find the link to the presentation?
How they
In the
feel.
chat? Not in the Zoom call.
Right?
I
Some
resend
people
it.
start
Ah,
using that
perfect.
in the market, you know, like Post Express, they deliver.
In case people are not able to join.
Yeah, I think it's just 10 minutes. It's, I will not
They're
open.
asking if we want to.
And they are targeting young audience, and they were started late.
So it seems that the PowerPoint is not working or is sort of blocked. So please just, as Wim already wrote in the chat, please enter your ideas or your thought directly in the chat. I think that's way easier.
Yes, we are thinking of organizing more of these boot camps, and we learn from this. Every day is a new adventure. So.
We have another 5 minutes.
You'll notice,
Just
you'll notice one of the
type
things
into the chat
she's
your thoughts.
disruptive.
So now we're back here with the comment in the chat. Thank you very much, all of you who typed them in. We need to open them.
Open the chat.
Yeah,
Uh-huh.
we can open it. So how did it go? I think many of you already entered your suggestions or ideas, proposals. So we'd like you to share with them. Like, just unmute yourself, pick your proposal, share them with the room. You can read them and maybe explain why you think that would be interesting. Which do you want to start? You were
Well, maybe let's pick somebody from the audience because I've been speaking quite a lot. So maybe
okay.
someone from the online audience.
Yeah. So someone who's online.
Paloma, I think you were the first one to share. Maybe you would like to unmute yourself and.
Yeah, sure.
Hi. Good to see you.
Hi, everyone. Good to see you as well. Yeah, I wrote in the chat room that I work with multimodal alignment in teacher-student interaction. So when I looked at the video, it just caught my attention that they constantly are mimicking each other's gestures and also lexical items. So then you could use, for example, motion tracking techniques to see gestures that are being mimicked, and also kind of see the directionality of this mimicry, who is kind of what we were talking yesterday about leader-follower dynamics, because it seemed as though there's one in the group that tends to give the ideas and the others elaborate on that, and they repeat certain lexical and gestural items. So that was an idea.
Can you please tell me what a lexical item is?
Yeah, basically I'm talking about words, just plainly said. But when they said, I don't have the word right now, but for example, on a gestural, he started doing like this sort of open palm gesture, and then she would repeat it and go like this, or a pointing gesture that was later incorporated by, I remember more the gestures than the lexical part, but I do recall that they resorted to similar words as well.
Cool, thank you.
That's great. Thank you.
You're welcome.
So
next one.
Yeah.
Or any comments or feedback?
This is brainstorming.
So how would we operationalize that then?
Yeah. This is a word I can't pronounce, baby. Operationalization. I'm better at typing this word.
Well, yeah, I'm tempted to move that to the research paper idea session, because I want you to hear about that from Professor Wolfgang Maass. His frameworks and all. So research paper ideas, and after would be more about operationalizing that. It's about seeing all the, but that is a typical, we move operationalizing, I need to just, operationalize,
So
awesome.
we wait for that.
Yeah.
So let's have a look at more possibilities.
Max is here with us, so come up.
Thank you. So I was just thinking of with the warm-up game, where we basically just give one word, and then we all just came up with kind of the same ideas a couple of times. And since language models just learn the patterns from the text you're training them on, I was curious what would happen if you train a language model on all the transcripts, because I assume there's a lot of them, and then see that maybe if you compare them to a more generalized language model, which is trained on books, for example, what would be the difference if you start with the same input, with the same prompt, and what would be the difference between the two language models? If maybe the designers use different words, maybe they go into a different direction. So yeah, that was my idea.
Yeah, I think you're in the right place to do that. You work with Gerard, right?
Yeah.
Yes. So.
Yes, we can.
Yes. Thank you for sharing. So now we have Alina Gregori. Hi.
So I was thinking one could maybe compare the amount and maybe also the type of gestures people use when talking only for themselves or by themselves versus in a conversation with others. Because I heard a talk on people practicing a presentation in front of only a wall or in front of a virtual reality audience. And I thought that was very interesting. And I think we could go deeper into that.
That's great. Thank you. Okay, now we have Jing Liu with your idea.
Yes, hi everyone. Yeah. So actually, I saw a lot of overlapping ideas with mine. So what I'm thinking is to use this as a data set to train a computational model to predict some coordination behaviors like turn taking, back channeling, or ground truth. So especially in this case, there are a lot of more than 2 agents are involved in the conversation. Actually, I will start the same kind of model training based on multi-model behaviors next semester. That one would be on children's behavior development, but it would be very interesting to treat the Envision dataset as a benchmarking as a kind of well-developed coordination strategy and to see whether there are some differences between these 2 models.
Oh, that's wonderful. Thank you. We've been talking with Jonathan a little bit about back channels. What I noticed, and it's not quantitative, that there were specific individual back channel strategies. So there was one guy who was always like repetitive and he was saying like, yep, 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 yep. And the girl was saying like, right. Always, only this, sometimes she would say yeah, but the guy would always repeat and then mostly with this yeah, yup things. And then there was one time when they kind of started like drifting into this like really abstract ideas of producing this material analyzer thing, redesigning it really together. When he started producing hair back channels, he started saying right. Yeah, so that's definitely something that.
You know, I'm struck by in music, in jazz, you're always picking up somebody else's thing, and there is a back channel aspect to playing, but it's an acknowledgement and saying, I'm picking up what you got, and I'm running, and I'm still working on it. In a way, it's kind of an open acknowledgement, and also saying, not I'm shelving it, but I'm working on that, hold on while I integrate it into this kind of thing. I hadn't even thought about back channeling until you said that, and it was like, right, yeah. Back channel. Yep.
Yeah, I would say it's really hard, especially in terms of the practical level. If we want to automatically to process everything, it is just very hard to annotate which parts would be the back channeling behaviors. And the working definition is, I would say, in demand in this case.
And that goes so contrary to how we teach people how to interact. It's all based on very, very simple, kind of the models we have are very often just my turn, your turn, his turn, wait your turn, instead of do back channeling. And sometimes back channeling, I've noticed, is in the gesture also, right? People don't object when they gesture over each other. People can object when they're talking, but again, I mean, it's kind of challenging a whole dogma of how we look at how people are supposed to interact in an orderly way, in a linear way, right? And so back channeling seems to be a really nice way into that.
Okay. So now we have James with your idea.
Well, should I move to the front or just sit here?
Yeah, how you as you prefer. So now I'm coming up the stairs to James.
Oh, fancy. Okay. I'll move my camera and then people know I exist. I'm here. Hello. Yeah, so my idea was basically to try to kind of combine the qualitative and quantitative aspects we talked about a bit. And basically, so my kind of, maybe what if would be kind of cool, as I put in the chat, is to kind of qualitatively say, this is like a brainstorming, like a loose back and forth kind of aspect. Here they're having a breakthrough, they're really coming up with something new. Here they're fine-tuning a particular idea. These kinds of different phases of this collaborative aspect. and then take something, I'm kind of just loosely thinking without really knowing how to do this methodologically yet, but thinking like this turn-taking entropy, the switching between people, in like a windowed approach, for example, to get it a bit more fine-grained and see if we can actually see if there's some sort of entropy pattern that is kind of specific to these different phases, where we say, indeed, there's something very orderly here that's fine for brainstorming, but maybe it becomes very chaotic, and that works very well when we're actually having a breakthrough, and then it becomes very orderly again for fine-tuning or some other kind of pattern. But just to see if there's some sort of kind of turn-taking dynamical pattern that maybe fits with these different phases even. I think that would be quite interesting to see more from a theoretical perspective of group behavior overall.
Anecdotally, I think that fine-tuning tends to be a little more sober. Anecdotally, but
yeah, so that'd be really cool to see if we can indeed quantify that and even see if maybe there's something even more fine-grained than that. Maybe it's not even just the kind of back and forth in different phases, but a certain kind of power dynamic that arises.
I was thinking about when you were talking about every motion has two motions actually. There's the ballistic and there's the kind of zero-in motion. And I was wondering if, in a sense, there's more ballistic going on in the non-fine-tuning moments, and there's more zeroing in on the fine-tuning moments. I'm wondering from what you said. It's a real question.
Yeah, that could be really interesting. Kind of relate this more kind of the motor aspect to higher up. I really like the going for something very, very small in human behavior and seeing that kind of scales up.
Even the one guy when he goes, so you get gesture, but then you control it like this, right? And so what we see is this big thing and then a fine tuning like this.
Thank you. I think next we have Andrea. So you heard Andrea's talk to Ludovica yesterday. One of the few so people can see you.
It's not fair because he could say that, you know. No, I mean, this thing of turn taking, it's very interesting. We have been using that in another study. And we were kind of making a difference in that case of, because turn taking is all about interruptions, right? And so we were distinguishing among successful and unsuccessful interruptions. And that is in the subsequent speech. So maybe the tone of the voice was changing and or there was a pause because I make an intervention and you don't know how to say and what to say. And so that is an unsuccessful interruption. Whereas if you interrupt me and we keep going at a speed, that is adding knowledge to the discourse. So I think it's something we should consider definitely, also because your analysis would be richer because you also have the gesture, and so the gesture could define what is a successful interruption and what is not. So maybe depending on your body language, you could say, okay, you killed me with your intervention, or this is really keeping me engaged. And well, this was about what we were saying yesterday mostly. So we could really use multimodal in the sense that they are all different features, and how do I integrate them to predict something? Because I mean, in my feeling, I would like to see, okay, I can predict performance, or I can predict learning behavior, or I can predict engagement or something like that. So either we make, I mean, with the help of Gerard, maybe a deep learning model or some machine learning other kind of approach, or a statistical model to say we use them as different features. But I think we could have a bigger opportunity here, because we could try mixed methodologies and say, okay, I'm coding gestures, but maybe I can put the code in the text. And I can code emotions with my tool. And so we can have multiple brands within the transcript, which could be a brand, some brands for emotions, some brands for gestures, and some other words that represent performance or team dynamics. And we could really study them together in a network. And that, from my perspective, would be beautiful and would also translate, because then for each team, for each person, you can have a semantic network. And so that fits very well with the idea of synchronicity. So you can study synchronicity of teams, even if they are disentangled physically, but they are in the same flow state, or you could study similarity. of team interaction. So that is basically a wrap up. Thank you.
Thank you, Andrea. Let's go with the next one in the chat. Gregor, you want to mute yourself and go ahead?
Hey, thanks. Sorry for bailing out earlier, but I had like a little computer problem. But I would like to suggest something that might be actually very lightweight and lowbrow. So, and something that actually could be done in 2 or 3 days, I think. So it's really easy, I think, to find the bits where somebody's talking. Like we can do that automatically. For all of these bits where somebody's talking, we get, it's easy to get the minimum and maximum and mean of the pitch. Now, Wim already sent me a link for the PVQ, pitch variation quotient, which could be a metric for perceived liveliness. So you would then have like, you basically would be able to tell if there's lots of variation in people speaking. So whether maybe if you have a team that goes like, what do we do now? I don't know. And as opposed to people that are on fire, as in the clip that we just seen, like, you know, we need to do this. Oh, this would be awesome. And then you have like all this liveliness and you're really acting out and drawing it. And then what you could do very easily is like you have all these utterances and you can plot them on a 2D space. And then you can see, for example, if they are getting more and more engaged, if they're ramping each other up, if you could track who's who, then you could even test if they are contagious, kind of like if you have somebody in the group who's really pushing it. That could be very interesting. And another thing that maybe final suggestion is like we might already know from the coding, I'm not sure, but there might be breakthrough points within the session where you really have an idea and then there's like a more quieter phase where everybody needs to write it down to secure it. Now, if you have like, you know, increase in expressive range and also volume, maybe over the course of time, and you can link that to specific events, like for example, where they really had a good idea and they were shouting at each other like, this is awesome, or something like that, then this could be really helpful. And the good thing about it is that it's relatively easy to do, and you can throw this, if it was a module or a pipeline, onto teachers, for pedagogy. You could do cross-cultural comparisons of like how people talk to each other. Are they more or less, you know, like it's scalable to other contexts. So there's yeah, that is something like, but yeah, thank you so much for listening.
Thank you, Gregor.
Awesome.
We have still many proposals in the chat, so let's try to go through them before we need to jump to the next session. So Katie, please jump ahead. Katie.
Can we see her?
Katie, Douglas, Katie. Maybe this is.
Hi.
Hi.
Hi, Katie.
Yeah, so basically my idea for the analysis was related to synchrony. So on synchrony levels, you can look at that from everything from like a broad body sway to like speech rhythm, rate and prosody, as well as gesture. And I thought that could be something cool to compare to group performance and potentially like comparing it on multiple levels, like number of idea generated throughout the session, as well as like whether or not maybe through like an inter-rater assessed process, teams are working collaboratively. So kind of a yes and model, as opposed to a more competitive model where like I know that you're saying that like in some sessions people were really putting up barriers, so that would be like a no but, and seeing if synchrony corresponds to these metrics of group performance.
That's lovely. So one guy was like, yes, going really, so I think there is something to that. Okay, thank you, Katie. Let's continue with Marlene Spaniel. Hi.
Hi. So I have been looking at the relation between turn taking and gaze behavior. And so far I've only looked at dyadic interactions. And for example, what we can find is that always when we're about to finish our turn, we tend to direct our gaze to our interlocutor to hand over. And so I think it would be really interesting to look in the videos of the design teams, which is a triadic interaction. How do these handovers of the turns work? Because I mean, everyone can then give the gaze to only one of the two interlocutors, and then it can be successful in a sense that this interlocutor will pick up and will be the next speaker, or it can be that the other one who is not intended to or has not given the role of the next speaker actually wants to jump in and say something. So I think it could be really interesting once to see how do speakers, how does the current speaker select the next speaker? So how do they hand over? Do they do certain body gestures or use the gaze to select the next speaker? And then what do the speakers do who want to speak but are not selected? Do they use the prosody or also some specific gestures or yeah?
Great, thank you so much, Marlene. Julia, would you go next?
Sorry. Yeah, no. For me, it's in fact it's the opposite than Kate, in a sense that I will be interested to look at desynchronization, in a sense that if I think often people when they tend to have a new understanding of something tend to be desynchronized. So I think it might be interesting to look at the desynchronization of the group, but also within individual, to see maybe to what extent desynchronization of one individual can spread to the other, to follow kind of the emergence of new ID, to see when if we consider the group as a system, if the system is a bit shaken, it might tend to generate new ID maybe. But in terms of method, yeah, I was talking a bit about trying to identify this tipping point, maybe using RQA or other method to identify this specific point where things are a bit unstable and new things can emerge.
Thank you very much. Yeah, you can do it together, and then you have synchrony and asynchrony. Okay, Mandy Klatt. Hi.
Yeah, hi. Yeah, when I saw the videos or the video, I thought about group collaboration, and I wrote down rather some questions I had when I were watching the video. So I would be interested to see how the groups work together. And I think for this, it would be, in a first step, really important to define what is group collaboration, and yeah, how can I measure group collaboration, and maybe something like turn taking. Are there any differences also between the different groups? And yeah, what behaviors do I use to determine this? So yeah, that are some questions I think are really interesting.
Thanks, that's great. I think we could elaborate on that for a very, very long time. We have definitely been through this process. So let's continue with Natasha, who is here in Potsdam with us. Do you want to come up?
Yeah. Come on down.
I can't really say no because I was complaining about sitting so much the other
Yes,
day.
some acrobatics.
Yeah. So, all right. So the idea that I had, I'm not exactly sure what I wrote, but the idea that I was getting at is kind of building on the levels that were that Jonathan, that you talked about, and saying, so if there are these spontaneous gestures where people are excited and they're thinking about, I mean, they're just communicating, right? But if you look at the gestures and see, so there are these different levels, might there be something in education for that? And the reason why that might be interesting is because when we're designing gestures for education, then instead of going from, I know what I'm talking about and I'm trying to communicate it to you, we have the opposite process. We're trying to get the body to contribute to the meaning that is supposed to be anchored long-term in the mind and body, and also be useful for speaking. So, what happens often in research is that people will do these, and I love gesture research, I love gesture researchers, but what you often read is, the experimenter came up with these gestures, or, they were taught and repeated 5 times, which gives you a certain aspect of the methodology, but it also leaves some holes because, so you have research, you know, gesture helps, and a teacher will say, okay, fantastic. So what do I do? And then the answer is often be spontaneous. It's not bad, right? I mean, being spontaneous is good. But if we have neuroscience and we have all of these concepts, we know so much about concepts and the body and how we learn, wouldn't it be interesting to take some of this data that takes a really long time to analyze? Yeah. And to say, okay, we have this idea about rules. How does it work? Is that something, because that would be advice at a very different level. And so if these patterns are in the data, that's something I would be interested in knowing more about.
Yes.
Thank you, Natasha. So now we have Jana Hosemann. Hi, Jana.
Hi. Actually, I'm not really sure if I can give in a really new idea because I'm coming from sign language research, and sign language research is always interested in sign gesture interfaces, or like, but basically focuses on sign language. So I don't know if there would be anything that could help you. Sorry.
Yes.
I think we could come up with something for sure. Thank you. Stephen, you want to join us, stretch your legs a little bit here too? Come on.
Yeah, so I am interested in, or have, so far worked on speech production and speech perception. I can take my mask off.
Yes, breathe.
I've so far worked on speech production, speech perception, interested in all of these, well, looking at multimodal research and the opportunities that this data set allows. And in particular, the question came up of how linguistic innovation and product innovation in this context might relate to each other, or whether, so the initial thought that I had was perhaps they're mutually exclusive, because successful communication depends on using a pretty standardized set of segments or patterns. And so, yeah, the question arises, is that the case? Or perhaps there are certain aspects of linguistic innovation that also support product innovation as measured with all of these.
There's evidence for that.
Okay.
And I can hook you up with that.
Great.
Super interesting stuff about new language being produced in reports.
Right.
That is correlated with high performance teams.
Interesting.
But not to the level you're talking about here,
Okay.
which is a
more open questions.
yeah,
still,
yeah, this is beautiful. Yeah.
Thank you very much, Stephen.
Remember, he even says, we need a name for this.
Yeah. And oh, sorry, it's going all the way. So I think we have covered all the messages that we had in the chat. If there are any other ideas or proposals, please feel free to write them down if they come up during the day. Also, at the end of the day, we're going to have research papers ideas session where we're going to further explore or further discuss some of the initial thought that we're providing during this session. Thank you very much, each one of you. Thank you very much, Ola here. For your openness and also to be part of trying to create this community. This is something very important, and that was part of the core purposes for doing the Envision Bootcamp. And now we're going to move to
technical break, so we can prepare the next speaker. You can get coffee again. You can quickly have a pee break. You can have a tea break. We're back at 11:30.
So we're back at 11:30. Thank you very much, and see you in a bit.
Yeah.
Wow, perfect time. So good.
And the recent sensation has been Spacy. It was developed in Berlin, and one of the co-founders is from my university. So she studied in University of Bonn as well, which I got to know a little later. And yes, I've been following Spacy from the start, but I mostly use NLTK for my task, but the documentation that Spacy has and all the new additions which they are having, the new algorithm, so it's quite good. So what we'll do is I'll just yeah, I'll just show you the web page of Spacy, so how it is like, and then we'll start with the hands-on. I have a Google Colab notebook. So how we can do it is, like, I will share the link in the chat, and people who want to do it along with me, they can try running the code themselves. So I'll be going through the notebook. So
yeah, I can also add to that. So NLTK was more of an academic project. So the idea was make it easy to teach natural language processing to beginners, whereas Spacy has a philosophy that makes it also very easy to use, but actually production ready. So a lot of companies can directly put Spacy into practical use in their products. And that's one of the differentiating factors of Spacy compared to NLTK.
I don't know if I missed it, but have we seen the web page of Spacy by itself? If I missed it, I apologize.
Can you said you were going to show the web page?
Just a second. I'm just trying to find the chat. I was struggling with it. Sorry. Just the so is it visible now, the screen? Okay, yes. So this is the web page, and they've recently updated. They have a new version 3.2, and many of the older things are not working. So many things are getting updated. So you need to be, it's a transition period. In Spacy, many new things are being added. So they have a nice introduction. They have a course as well. Can do it. They have some videos, which is interesting. And so as Professor Melo mentioned, it's so they say that it's mainly for production use, and they themselves give acknowledgement to NLTK that's more of research oriented, and that's better for academia. NLTK, that's what they tell, and they have these features, and it's very nicely explained. So that's the main appealing factor in Spacy. The documentation is really good. So yeah, they have these initial things, the pipelines, the linguistic annotations, and similarity. So those kinds of things I'll be covering in the notebook. So I've shared the link in the chat. So you can do it along with me. So I'll be going through the slides, and you can go through it, or you can also run things along with me. So for people who don't know Google Colab, Google provides, so there is Jupyter Notebooks. So similarly, Google provides Google Colabs, and we can also use GPUs over here. They provide GPU support. So currently I'm just using a CPU, but you can also add GPUs in the runtime. Here you can just use a GPU. So that's about Google Colab, and in fact, Spacy is already installed in this particular notebook. I'm just doing it so that people are aware of how to install Spacy. So this is a very basic implementation. You can just do a pip install of Spacy, and there are other ways of doing it as well. You can use a Conda environment. There's something known as Anaconda, where you can use virtual environments, and the virtual environments is mostly on your local system or on a server. So here, the Spacy is sufficient. And if something is not clear, you can ask me. You can stop and ask me. So just do a Spacy install,
Right,
and then.
so, yeah, for those of you not yet familiar with Google Colab, so you click on the little play button to run that command, and then yeah, that will run that cell. And it's similar to Jupyter notebooks that we had been showing, but it's all already provided by Google, and so easy to use, nothing to install. You can just go on the link and start your own instance.
Yes, so
Do it in the
this
cloud.
is the button which you need.
That's also the GPU that from Google servers, or
Whoever, you can all run, open this notebook, and each of you who opens it would get your own instance, and that would be running in the cloud on Google servers. So you can get access to powerful machines. Even if your own laptop is very weak, you can then run on a GPU, some of the more sophisticated things. But for here, the things we're going to show here, you don't need a GPU.
Yes, and in order to use this, I think everyone needs to log in with a Gmail account to run along with me, I guess. So after installing Spacy, I'm just not doing the installations, but I think I can run the rest of the things. Then there are some statistical models which Spacy provides. So this is the model. So SM means small. So they have a small model, a medium, and a large. So small is a, so it's, as you see, it's just 12 MBs, and it's just for the basic processing pipeline, whatever we want to try. So here I'm just using the small model, and since Spacy is have updated the versions, installing the medium and the large, there is some issue with that. I think they're still figuring it out. So we'll just use the small models. So this would come into picture mainly for vectors. So when we're working with vectors, contextual vectors, so that I'll cover those things in a bit. So this would take a few seconds to run. So this is how you run it. You just click on this and it'll be loaded. And then you need to import Spacy. Just say import Spacy. Again, this you need to run. And after that, to load a model, one of the statistical models, you just use spacy.load. And then it creates an NLP pipeline. So it's a processing pipeline which Spacy has. So this is how the processing pipeline looks like. When you feed in a text into this NLP pipeline, it does all these actions. So it does tokenization, tagging, parsing, NERL. I'll cover each of these tasks in a bit, and then it creates a document object. So here, so we just have this text, piece of text, which says, Apple is looking at buying UK startup for 1 billion. So we just, there's another shortcut to run this. So you can either click this, or if you're from your keyboard, you can just use Shift and Enter. That's more convenient, I guess. You can just do Shift and Enter, and then it just goes to the, it runs it and it just goes to the next code block. So it loads the text, and then we pass this text into this NLP pipeline, and then it creates the document object. So all of these actions have been performed, and we just need to access the results from this document object. And when you just do NLP dot, so NLP is the pipeline which we created from here, which we loaded from this particular code block, which has the model loaded. And then if you do pipeline, it just shows what all properties are present. It has a tagger, a parser, and it has NER, which is name entity recognition. Yeah, so first we'll start with tokenization. So tokenization is when you have a text, a piece of text, you can split it into tokens. So that can be done in many ways. So the most simple or the basic way to do it is just splitting it by using spaces, because each of the words would be separated by spaces. You can also split it with, for example, some characters like a comma or a semicolon and so on. Just showing this as an example to see how Spacy works differently from here.
So tokens is just a term that generalizes words and other kinds of symbols that might be in the input. So basically splitting it into words and other kinds of punctuation.
Yeah. So this was done using a simple text.split. So this is a normal split function. Here we haven't used Spacy. You can just see that it's been split based on a small empty space. And then we already have this document object, which was created over here. We're passing the text. And then you can see the output. So you can clearly see the difference that, for example, dollar and one. So both of them are in the same word. But in Spacy, what it does is it internally has a rule-based tokenizer. So it considers dollars separately. It considers each of the symbols separately. So even, for example, billion and exclamation is in the same word. When it do a simple split in Spacy, it does split exclamation as a separate token. So this tokenization it's pretty good in Spacy when compared to NLTK and compared to NLTK. So one of the comparisons which we can do to Spacy, which I can think of, is always NLTK, the basic NLP task processing. So that's about tokenization.
So we can, a basic splitting by space might seem a good initial step, but that doesn't really work because whenever you have a comma, it just remains attached to a word. And so if you want to count word frequencies, you need to deal with all these subtleties like quotation marks and exclamation marks. And so it's always good to use a tokenizer from a tool like Spacy.
So I hope everyone is able to follow, and then we have the part of
your font size a bit so that it's a bit bigger, easier to see. Yeah, thanks.
Better? Okay.
Even bigger if you want, or is this fine? All right.
Oh, that's better, yeah.
This is okay.
Or this, or it depends on how much text you have. Even bigger could also be useful.
That's way better for me, yeah.
All right, yeah, that's good.
Okay.
Some of us are a bit older.
So then we have this part of speech tags. So basically, we are just going through the processing pipeline which NLP has using this document object. We've already done the processing. We're just accessing that object and trying to infer output based on the task. So we already did for tokenization, and now part of speech tagging. So when there is a text, the basic thing would be to do tokenization. So one of the pre-processing steps would be tokenization, and then you move on to part of speech tagging. So part of speech tags are basically you have these proper nouns, verbs, adverbs. So each of the tokens would be assigned to a particular tag. So that's what's happening here. And in this particular code block from the document object, we run a for loop for each token. We're just printing the token and the lemma. So it also does lemmatization. Lemmatization is basically reducing the word to its original form, the root form. And so there is
Looking
also
becomes look, and all the other variants like looked, past tense would also just become look. So that can be useful if you want to just compute statistics over verbs and not have to have all these different forms separately. Then you can just count what verbs are being used irrespective of the particular form.
Yes, that's lemma, and then so then we get the part of speech tag, which is so apple is a proper noun and looking is a verb. So startup is a noun and so on. So even punctuation is identified over here. So this is the output from Spacy, from the basic Spacy statistical model. And we also have something interesting over here, which just gives shape. So here we have some pattern. We have a pattern which says the capital X means A is in the uppercase, and the small x means it's lowercase. So that's a pattern of that particular token. That's also we're getting that as also one of the outputs. And if you check UK U dot K, so the dot is considered separately, and I'm not sure what the D is, but yeah, this is a cool feature. And then we have is alphanumerical, and then is stop word. So then there are these stop words which we would want to remove from the text for processing before training a model. Stop words are like the words like is, at, and for example for. So these are very common words which might not make much of a difference even if it's being removed. So you just remove those words and do the processing when you try to train a model or do any kind of task. So this
depends a lot
particular
on the task. So if you're doing sentiment analysis, or if you're doing relationships, then it does matter, like if something was done with someone or against someone. But if you're just trying to get a general classification model that is figuring out what is this document about, then it's not really about for or about the word against. It's more about, you care more about the key topic words. And so in those cases, you can remove anything that's labeled as a stop word.
Yeah, so this is about the part of speech tagging. So we can get a cool output like this from here, from the Spacy object.
And you can see there's a distinction between the coarse-grained classes like proper noun, and then there are some additional tags behind it like NNP, VBZ, and so on. So those are more fine-grained tags if you want to figure out particular forms of the verbs. There are also more details in there that can enable you to do finer-grained analyses, like are a lot of past tense verbs being used. So those could also be interesting to look into. Which particular orientation does a text have? Is it using a lot of past tense or present tense, those kinds of things?
Yeah. So for most of us, few of the things might not be very common, right? For example, ADP or NNP. So if you want to know what each of it means, Spacy provides another function. You can just do spacy.explain of that particular term, and then it says what it means. So it just means proper noun, and we can just try what is NNP, and it says noun proper singular. So whatever output we get, we can do this, and we can understand what this means. So I think that's a good feature as well.
I think any library should have this feature in the future. It would be great.
Yes.
Yes, most of the time I'd be wasting searching what this means, what that means. So this is a very good feature. And then we have dependency parsing. So whenever you have a sentence, So dependency parsing is like the process of analyzing the grammatical structure of a sentence based on the dependencies between the words in a sentence. So what this particular output block means is that this is the token Apple, and it gives you the dependency tag. So it says NSUBJ. So we can just see what that means. This means nominal subject, and then it also gives the head text, something known as head text, and the head position. So there's a visualizer below, so we can make more sense out of it rather than reading it here, which would be more interesting. So I'll just show you. We get this kind of an output. Over here, we can get the dependency tag, the head, something known as head, and the position of the head, the part of speech of the head tag. And yes, so I'll just come to that visualizer in a bit. And then we also have this named entity recognizer recognition. So this pipeline also gives us so basically what named entity recognition means, whenever you have a text and you need to know what the entity, so a text would be having entities, right? There in this particular text, Apple is looking at buying UK startup for $1 billion. There are certain entities present. So for example, Apple is an entity and UK is an entity and $1 billion. So that's what this particular code block identifies. The pipeline identifies Apple as an entity. In name entity recognition, it gives it attaches a type to that entity. So Apple belongs to the type organization, and UK is GPE. So GPE means countries, cities, states. So again, I use this explain, which is nice. And $1 million mean it is attached to that category money. So
GPEs are geopolitical entities. So anything that could be countries, cities, state, region, and so on. There's so many different labels for it. So the abstract term is just geopolitical entities.
Yes, and there are many more labels, and we can even define our own user-defined labels while training the model. So this seems to be pretty accurate, the name entity recognition, and so this is a very useful task, a very basic task in NLP, I would say. And then we can visualize a few things using Spacy. So there's something known as Displacy. Just need to import Displacy using this particular command. And there are two ways which you can do this. You can use displacy.serve of the document object, and the style is equal to DEP. DEP means dependency parser. So you will get the output of the dependency parser from the current document object. So if you do display.serve in your local system, you can access it using your browser using this particular link. But since I'm using Colab, I won't be able to do this.
It would work if you had your own Jupyter notebook or you ran the software on your own computer. But since now it's running remotely on another server, that URL wouldn't work. So yeah, this is when we just use displacy.render.
Yes, so and then you just have some attributes, and you can even mention the distance, which decides the length of this particular visualization. So maybe I just need to zoom out a bit to show this. So here you can see what each token refers to. The POS tags are below, and here it shows the dependency. So looking, this is kind of the so here if you try to compare the output from here it gives token.head text is the third item. And for Apple, so it says looking is the head. And then you get the POS tag of looking. So here you're just trying to see here. So for looking, for Apple, looking is the head. And similarly, so basically these two words depend on looking, and so on. Here, startup, the head would be UK. So that's what the output was given over there, and you get a good visualization. You can see the dependency between each of the words. What are the head and the tail? So this would be useful in some of the downstream NLP tasks. So
this
we
is
can
the
also
general structure of a sentence, and it's a little bit different than regular syntax trees that you study in linguistics, but not entirely different. It's a different kind of formalism, but the basic thing you see here is that looking, if you look at the whole sentence, then looking is the key event that's going on, and then all the links going out of there are basically describing the arguments of looking. So who is doing the looking? Well, the subject is Apple. Apple is doing the looking, and the looking is happening at some sort of buying event, and that whole buying event has its own children. So it's a quite complex tree in this case. And you can then dive deeper into what kind of buying event it is. So that's how it reveals the overall structure of what is going on in this kind of sentence. There's a looking event, and that looking event is being done by Apple, and you're looking at a buying event, and that buying event then also has all its various arguments.
So, so I'll just zoom in a bit again. So that was the dependency parsing. You can also visualize NER tags over here. So here it's just a small sentence. Here you can see that Apple is the entity and its type is highlighted over here. And similarly, UK is GPE. And then we have money. So if it's a big sentence, and when we use this visualization, it will be more easier to identify the entities when you want to visualize it. So this is interesting as well. So basically, this is the output from the named entity recognition task, whatever we did here. So everything is present in the document object. And what we do is we just call the document object in the render, and just the difference is ENT. So style, you mention ENT and you get the entities, and if you mention DEP, you get the dependency graph. So that's it about the display. So you just have these two visualizations as of now. And Spacy also provides something known as Spacy matcher, which is quite similar to regular expressions. You can say it makes matching items pretty simpler. So for that, you need to import matcher. So Spacy from spacy.matcher, and you do an import matcher. And the NLP pipeline, which you already loaded, we use that. And it loads all the vocabulary present in that particular model, the pre-trained model, which we loaded initially. And then we give it a new sentence to the object, the NLP pipeline. And we get the document object over here. We're just repeating it. So now we got a new document object. So here, what we do is we define patterns, and we add those patterns as rules to the matcher. And then we try to match, try to find patterns. So here we give a pattern like text, and text is lemon, and again, text water. This is one of the patterns. We add it as a rule. when we pass this document object, which has this particular sentence, and it tries to match, it gives us some ID, which means there is a match for this particular pattern. So whenever you get an ID, it means there is a match. I don't know what exactly this ID means, but refers to, but it's just it means there is a match. And 6 and 8 refers to the items which match. So lemon and water. So which means there is a match. So you can give even more complex patterns. Here we're just printing the same result. So here we're just getting some numbers. Here we wanted to see what exactly the match was. So we just take the output which is matches, and it has these 3 items. So match ID, start and end. And you try to get the start and end indexes in this particular text. And so you get lemon water, which was the matched item.
So in this case, it's not very exciting.
Mm-hmm.
I mean, you could much easily, there are many easy ways to search for lemon water, but now we'll see how this matcher framework actually enables you to do things you couldn't do without an NLP toolkit in the next example.
Yes. So here we have 2 sentences. So one is, did you read this book? And another one is, I will book my tickets. So here you can see that there is book. Book is common between both the sentences. The first sentence, book is a noun. And the second one, book is kind of a verb. It's a verb. And then we have a pattern where we define text, which is book, and the part of speech tag noun. So which means when we try to match, get a pattern from each of the sentences after passing it through the matcher, you need to get the term book, which is a noun. After adding the rule, what we do is we use that particular matcher which has this rule, and the first document get a match ID, because this book is present and it is also a noun, and you also get the start and end indexes. But in the second document, book is still present, but there is no match. The reason being that we also give a condition saying it should be a noun, the part of speech tag, which means a noun, but in this case it is a verb. So we don't get a match over here. So which is, yeah. And you can also do match patterns for phone numbers, email IDs. You can give patterns, and it simply does it. And their webpage, they call this Spacy matcher as regular expression on steroids. So that's the term they give for this particular matcher.
Very flexible framework, so you can dive deep into how to build on this and look for very specific things in your data. And I mean, nothing prevents us from including other kinds of extra annotations embedded within the transcripts, and then we could also look for sentences which had a particular gesture and so on. So we could build on these kinds of techniques to add more kinds of analyses.
So are you suggesting that we could use this as a start for then we could put kinds of gestures in?
Well, so the toolkit on its own doesn't have any capabilities for dealing with gestures or other extra paralinguistic or non-standard elements, but in general, we can use some tricks to kind of sneak them in as additional annotations, and then we can, I mean, there are very simple things like just adding some extra tokens at the end of or between sentences and so on, or you could do it at a more lower level and add them to the objects. So there are many things we can try.
Okay.
But that's what I'm thinking, that we can combine the capabilities that exist for text with additional annotations.
That's gigantic, right? I mean, it's basically saying what happens when we bring NLP together with gestural studies.
Right.
It's
Yeah.
fantastic. Yeah. Cool.
All right.
So yeah, so that's about the Spacy matcher, and then we'll move on to similarities. So we'll play around with a little bit with vectors. So these models, which Spacy already has, they have 3 models, as I already mentioned. They have a small, medium, and a large. The small one is basically, it doesn't have contextual vectors. So we have to load either the large or a medium model, which is trained on a more, a bigger corpus. So the small one is trained on, I think, onto text, a corpus called as onto text, but the large one is trained on web crawl, which is a much bigger corpus, and it has around 1 million vectors. So they suggest to use this particular model, but since there's something going on with the versions, was not able to download and load it. So which means I have to use the small model. So we might not get very good results when you're trying to do similarity. But after some time, I guess it should be fine. You would be able to download these things, and the larger models, and the similarity should be good. So, when it comes to vectors, each token would be having a vector in this particular pre-trained model. So you can call it a vector, or you can call it as word embeddings. So words in the vector space are known as word embeddings. There is a very basic and a popular model known as word2vec, which was from Google. So it is trained on a huge corpus, and so they just make it available for everyone to use it. So that can also be loaded and tried to use here, but we're just trying to use the Spacy model. I think they have used a CNN architecture to create these embeddings on the corpuses which I mentioned. So we'll just see how two documents, when we compare two documents, how similar two documents are in this particular code block. So we have these 3 sentences, and we get the, we pass it through the NLP object, and we get the documents, right? The document object, so which NLP gives us. And in order to use similarity, you just need to say document for document object of the first sentence dot similarity of document object of the second sentence. So which gives you a score of 0.36. So which means I like salty fries and hamburgers versus fast food tastes very good. So when you compare how similar these 2 sentences are, it gives you a similarity score of 0.36. So similarity scores would be typically from, I would start from 0. The range would be from 0 to 1. I think internally they're using cosine similarity over here. So starts from 0 to 1. So 1 being most similar, and 0 being not similar at all, or dissimilar. So 0.36 is okay, it's not so similar. But when you look at the sentences, it doesn't have common words in the first 2 sentences, but the meaning, it kind of refers to food, and yeah, it kinds of food, it refers to food. So when you try to compare the first and the third sentence, you get an even lower score, which is 0.24. So all these comparisons are comparison between vectors. So this model would be having vectors for each of the tokens present in the sentences, and it would try to, I guess it would try to do an aggregation of these vectors, and then do a cosine similarity. So that's what this particular similarity does, and you get a score over here. And interesting part is the last sentence. The last comparison, which is between document 2 and 3. So here you can see there are some common words, fast, and so very good is common. So you get a better similarity. The problem with so fast food tastes very good and fast shipments are very good, which means these two are two different things. So, but what this basic model sees is that if there are some common words available, and it just takes those vectors and then finds the similarity. But what we are actually looking for is some context. When you take the context into account, it's wrong. So that's the problem with these. When I initially mentioned that we had to load the larger ones, so this is the exact issue when we use the smaller model. So that's where the larger ones trained on a huge corpus and on a sophisticated architecture, which takes context into picture. So there are some models like transformers, something known as BERT, which has been the buzzword for the past 2-3 years in the NLP community. Everyone uses BERT. So it is a transformer model which takes context into account, and there are many other models as well prior to that. So
right. So with those kinds of models, then we could get even these subtle distinctions made properly. So then it would assess that the first two documents are talking about food and they're actually quite similar despite using very different words. And the third one is talking about something different despite using similar words. So here we see that even a human that isn't careful might think the last two sentences are somewhat similar. And then because a bunch of words are similar, but a good model can recognize the difference, that the third sentence is just talking about something completely different. And so a couple of years ago, we still had trouble with these kinds of scenarios, and you can see the small model still has trouble making the distinction, but now we've reached a level where the models can properly figure these things out.
It's funny, there's a wonderful ambiguity in this, because if we're talking about fastness, maybe fast is what's important, right? But if we're talking about food, unless we're talking about deliveries or salty deliveries.
Fast delivery is important, is very good. And then you might be talking about your food delivery. So there's a lot of context that matters. And that's what we found as well. These initial models, the very simple ones, they kind of aggregate the whole thing into one vector without really looking at where a particular word occurs and what the particular context is like. But now the latest models, you can feed in more and more context, and then it tries to check how that context fits in with whatever you're saying. And so we could add the broader dialogue context. What were they talking about before? What are they going to be talking about next? And then the model can try to figure out, is this a food delivery or is this some computer delivery that I'm talking about, and distinguish these cases.
What about things like homonyms, like pair and pair? I mean, which we may deliberately be using, you know.
Oh, absolutely. All right.
Yeah. Because again, I'm going back to the poetry as a hard case, right?
Oh yeah.
I can say I know, and meaning K-N-O-W, but I can say I know and O, no, K-N-O-W, that kind of thing.
Right.
And to the ear, it's deliberately playing with those, right? Mm-hmm. Is there work in functions or some kind of function which begins to go, the phoneme is actually the same, so it can be different things in the same context, actually.
Yeah, dealing with homonyms, polysemy, all these issues used to be a big challenge, but now the models have gotten better at it just by looking at more context and also by not treating every word as one unit, but going into the words and looking at their composition. So capturing certain patterns within the structure of a word. And so actually, we've been starting to see nice results also in poetry generation, lacking the kind of human creative spirit that a human would put into it, but still at first glance kind of looking okay. And so there's some work on this, and it's ongoing, and people are looking how to incorporate metaphor into poetry generation and different kind of stylistic elements. And so there is work on this, but it's still early, and we'll have to see how far you can get without having an actual agent, conscious being thinking about things, thinking about the world, and which is something we usually expect from true poetry.
Right, right. Yes, that's absolutely correct. Yeah.
How are we time-wise?
It's my fault. He started later, but I've also let him know in chat that we can wrap up here and also follow up in the reflection sessions later.
Right.
You could just quickly also just say some things, Manoj, and
Yeah, I can quickly show. I just have a couple more things. Maybe can I have 2 more minutes? I can just show. So yeah, I mean, we just have some more things about similarity. So here we can just access the vectors. This particular code block, you can check if a particular token whether it has a vector and what is the vector normalization. And this is how you access the vector. You take each of the tokens, and so token.text would give you the text, and length would give you the length of the vector, and dot vector would be giving you the actual vector, which has the size of the vector is 96. So you just get the vector like this. And we've also done some more similarity comparison between these 3 words. So queen, king, and chef. So queen and queen. So it's similar. It's the same word. So you get a score of 1, queen and king. You get 0.75, and queen and chef 0.33. So yeah, this is like a yeah, that's one of the comparisons. And maybe I can skip this part. It's quite similar. I just wanted to do some hands-on with this. It's similar to what we saw earlier, the fast food example. So we have Labrador all over here, and then you try to do a comparison between all 3 sentences. But you can see that the similarity is quite low. So here, and then I wanted to show about training, how to train a sample model. We already have the small model present. We load that model, and what we want to train here is an NER. So NER is named recognition task. So we add it to the pipe. So NLP is the pipeline which we create from here, and then you add it to that pipe, and this is the training data. Just have some sample training data where we have a sentence and the annotation present over here. So annotation is the entities and the start and end indexes and what type this particular entity belongs to. So Walmart is the entity, the start and end index, and the ORG is the organization. So that's the type. So we have all these annotations in this training data. And so here we add those labels to the NER object which we created here. We add it to them, and then we train the model using a code block. So this might change pretty soon because Spacy has changed the way models are being trained. For example, NLP.update is this is the main block where you give these the sentences, the annotations, and you mention the dropout values and the losses. So this is the main part, but this would be changed in the newer version. So just a very brief way to mention this training part. We have 30 iterations over here, and then randomly shuffle the training data. And we have batches. Batch size is mentioned over here, and then each of the batches, there is text that each of the sentences and its annotation that is passed to the NLP.update. So this is the main function, and this code block just trains it, and you get the losses. You can see for 30 iterations, so you can see the loss is reducing, and at some point you get 0.37. So which means it is trained well. What we are doing here is we are just fine-tuning the existing model. We're just adding more examples to it. We're not training it from scratch. So the output should be quite good. And so this is the output. The output model, what we do is we save it to a directory and again, load it from the directory. And here you can see that I was driving Alto is a test sentence. It was not present in the training sentence. And here you can see that Alto has been identified as the entity, and it says it's a product. So Alto is a car. So it has been identified, and we can also use the same sentence which we used earlier for the earlier examples. So here you can see that it has identified correctly the entities and the types. And there is another feature known as BIO or IOB. So, I mean, I don't know if it might be a little confusing, but I'll try to explain it where.
I don't think we need these details.
Need this? Later.
So
okay.
That's just a technical detail.
Okay, I'll leave that. And then Spacy also has something called Spacy text blob, which allows us to do sentiment analysis. So for this, just need to import, install the Spacy text blob. This is pretty new as well. Need to import it, and then same thing. So whenever you want to add a new feature to Spacy pipeline, you just do the pipeline object.add pipe, and then you pass the text, you get a document object. So what it does is it gives you polarity and subjectivity scores. So polarity is on a scale of -1 to 1, I guess. So if it goes into negative, it's negative, and towards 1 is positive in sentiment analysis.
This refers to the sentiment polarity. The valence is something more negative, horrible day, worst day ever. So you're getting a negative score there, and also it's a very subjective experience, so it's high subjectivity.
Yes, and this is just a small code block from the transcripts. I was not able to get a proper structure where I could load all the data and perform better analysis. So I just copy pasted a few things. So, and then generated a word cloud just to show you what has been used more. So, and we do the same sentiment analysis on the transcript text, and can see on each of the text what is the polarity and subjectivity. And it also shows something known as assessments, where which particular word influences these scores. So in this sentence, okay is the word which influences the polarity and subjectivity. And if you see in this sentence, you don't get any values because it doesn't find any particular word which affects either the polarity or the subjectivity. And yeah, so that's about Spacy text blob, and there are some references here as well which you can take a look at it later. Yeah,
so we could trace new nouns coming in and the types of nouns, the sentiment of the nouns, for example.
Yeah, we could keep track of nouns. We could identify new categories that we want to tag and recognize. All of that could be done. We'll have to brainstorm a bit
that's
on how to do it, but we'll be in touch about that.
Okay, thank you.
Thank you very much. Thanks, Manoj. Thanks, Joe. I don't want to be the bad timer, but yeah, we're going to have a very fast lunch. Professor Wolfgang Maass.
Fast food is tasty.
Yep. So, and then we'll be back at exactly 12:59.
12:59. We start at 1.
12:59 because we start exactly at 1. 12:59. So just enjoy the fast food. Thanks.
Thank you.
Thank you.
And yeah, thank you. Thanks for the opportunity.
So I took down some notes.
So, jetzt müssen wir uns hören. Bitte nicht stören am Flugmodus. Hallo? Also Mikro ist an. Und Lautsprecher? Ich glaube, niemand hat das Mikro außer uns. Deswegen haben wir niemanden. Okay. Und da links sehe ich dann den Gesamtbild vom Zoom und rechts den Chat. Das war super. Also ich bin Content jetzt mittlerweile hier, hast du super eingerichtet. Super. Also ja, es kommt noch der Bildschirm da oben, damit man vielleicht. Achso, da sind schon die. Nee, das war vorher. Ich habe einen Ständer gekauft. Also genau, weil jetzt hört man sie auch. Ich höre noch nichts. Das sagt ja keiner, was ist. Das ist immer eben könnte. Also, tippen kann ich hier, oder was? Dann muss ich auf die erst aufs Fenster gehen. Ja, okay. Mach erstmal das fertig. Also den Zoom-Chat, den tippen geht nicht, glaube ich. Ach, kann ich nicht. Nee. Okay. Kannst du das Fenster wieder zurückgeben, damit ich dann sehe, was.
Hi, Professor Maass. Can you hear me? Mic check.
Kurze Frage, hört man uns? Hallo?
Ja.
Mic check. Can you hear us?
Yes.
Good. Awesome. Welcome.
Okay.
Okay, so I will do a quick introduction of you, and then we start just exactly when I'm done. I will keep it short, since I'm reading it. So, everyone, welcome from the very fast lunch break. We're here in Potsdam. He would probably say a bit about where he's dialing in from, but I'll go straight into it. So, Professor Dr. Wolfgang Maass is a professor of business informatics and a professor of computer science, so joint appointment at Saarland University. He's the scientific director at the German Research Center for Artificial Intelligence, that is DFKI, and an adjunct professor at Stony Brook University School of Medicine. He studied computer science at RWTH Aachen and Saarland University. His PhD in computer science at Saarland University was funded by the German National Science Foundation, DFG. He investigated incremental natural language root descriptions. He was a postdoc researcher at the University of St. Gallen, where he received his habilitation from the Department of Management. Previously, he was a professor of media informatics at Fort Wangen University and a guest professor in the Department of Bioinformatics and Computational Biology at MD Anderson Cancer Center, University of Texas, and in the Department of Biomedical Informatics at Stony Brook University Health Sciences, Center School of Medicine. His research investigates the relationship between conceptual modeling and AI/ML, AI in distributed environments, and the design of smart devices. Additionally, he has a strong focus on knowledge transfer to industry to funded projects and spin-offs. He was a private lecturer at the University of St. Gallen and professor for media informatics at the RFU. In addition to his research activities, he worked as a consultant for Diebold Management Consulting, and he's going to present us today a very special paper that is one of the foundations of my dissertation, actually. Data-driven meets theory-driven research in the era of big data, opportunities and challenges for information systems research. So please a round of applause for Professor Dr.
Mr. Oele, thank you very much for this wonderful introduction, and this, I'm very happy to give this presentation. Unfortunately, I cannot be on site, which I really wished I could, and I hope that in the future it will be possible, because you are a community that is working with multimodal interaction, multimodal systems. Originally, I come from that kind of area. When I started my work here at DFKI in Saarbrücken as a student, I was working on multimodal interaction in the context of navigation. So I might have a basic idea of what you are actually doing. It's a wonderful area, and I hope that you had a very good time under severe conditions. But I have seen the videos online and the website, really great what you are doing. And in this sense, or with having that said, I hope that I can make a contribution to your workshop. I was really happy when Mr. Oele asked me to present our paper that I have jointly worked on with several colleagues from the US and Canada. I'm going to present the details about that. But on the other hand side, let's make that interactive. Even though it's distance and I only see these little tiny video streams, but let's try as good as we can to become interactive. Unfortunately, I cannot type into the Zoom chat window myself, but I read what you write on Zoom. You as a multimodal experts, you know, we have set up a green room here with OBS and all these kind of things with cameras and lighting and all this. So we did our very best in order to have a proper setup. So if you have a question, you can use chat, you can immediately use the microphone. Let's make that interactive as possible. Okay, let me start. A little bit of a background of what we are doing. I mean, this is my team, my group. We are at DFKI, one of the groups, or the only group that bridges business administration and computer science. All of my other colleagues are mostly, not all of them, but most of them are hardcore computer scientists, but we are looking in what we call, or what is called smart service, which tries to translate problem statements with the help of data and artificial intelligence into some solutions that help us to make better decisions. Decisions in the context of companies, decisions in the context of machine-to-machine communication, so that another machine can build on what the previous machine came up with and use that for subsequent decision making. Or it could be also end users, consumers. We work a lot in the area of healthcare and in a very special area of doping analytics, where we are analyzing urine samples of Olympic participants. And there are very interesting ways how they try to cheat and to investigate that. And what you need is to come up with services based on data analytics. And there is a lot to learn how lawyers are using that kind of information. That should be only just an example to see that the idea of smart service is rather broad. Yep. In our case, we are reaching from mechanical engineering, where we work with large machines, with laser cutting machines and all these kind of things on one hand side. On the other hand side, very down to earth, very natural things like investigating how shoppers in shopping environments, how they react by leveraging data that we collect via biosensors. Yeah, this all goes this way, and in extension to what computer scientists do, and I think I will emphasize that in this talk, is a computer scientist is mainly interested in having algorithmic solutions that are technically better than previous ones. Algorithmic means that the complexity is in a better class, means in a lower class. The runtime behavior is faster, resource consumption is reduced. Yeah, these are the parameters that are used in order to assess whether an algorithmic solution is better and whether it is a scientific insight. While if you think from the perspective what that means for people, for societies, for groups, for companies, you have to translate that into the behavioral world. And multimodal systems, as at least part of it, is related to HCI research. HCI is also going that path in order to say we need to evaluate user behavior when we provide certain kind of systems. While information systems goes one step further, it was originated from the idea of management information systems, which is strongly influenced by decision making. Yeah, by the decision theory in order to make decisions on a company level. And there, the concept of utility is core, as it is core in business administration in general. Okay, when I talk about information systems perspective, so for some of you, it is most likely an area where you haven't studied much about information systems, or as it is called as a sister discipline in Germany, it's called Wirtschaftsinformatik. While Wirtschaftsinformatik is more interested in designing systems similar to SAP. Yeah, SAP and Wirtschaftsinformatik are very close together, so supporting business processes. While business informatics has a stronger focus on the computational side, and it is related to data analytics. So I'm happy to discuss with you the boundaries of all these fields. It's sometimes a little bit confusing, but information systems perspective tries to understand the collaboration between technical solution and humans. Yeah, single humans, groups, society, companies. Okay, how this interplay works. And machine learning became very important recently, or not recently, for more than 10, 15 years. It became clear that information systems research should strongly look into what artificial intelligence is doing. Actually, for management information systems, expert systems in the 80s were the founding factor for management information systems in general. But now artificial intelligence with, in particular with machine learning, comes back big as a huge issue in information systems. But we take a different stand than computer scientists on that, because we want to understand how it affects decision making and organizations in general. So this here is from a recent discussion that we had in one of our top journals, MISQ, about the role of machine learning in information systems. And I use that only as a starting point for the paper that I'm going to report on in the second part. So methods to automatically detect patterns in data, use them to predict outcomes or take decisions. Yeah, so you see, it is not only that we deploy machine learning and then we are happy if we have an accuracy of 99% or 90% or something, yeah, or if you have an area under the curve of 0.8 or something, yeah. No, it is a question, what does it mean? What is the utility in particular when you make decisions, be it as a consumer or in a company? You know all this about the role or the technologies about supervised and predictive learning. Then the classification is, what is the value of that? We can go on this list: single outcome binary or multi-class classification, unsupervised learning and reinforced learning. These are the techniques that we deploy, and we try to see whether they help us to learn something on the theoretical side when it comes to information systems, and in particular decision-making on the organizational level. So opportunities, if we only replicate what computer scientists are doing, there is no need to doing research in information systems. So there needs to be something more. Yeah, so we take the methods inspired by real-world application that incorporate unique features of the domain. That means, in contrast to many things in computer science where the domain is not so important where you deploy that, it is more to show that in principle it works. In information systems research, the domain is absolutely key, and you try to derive and to see what kind of theory can be extracted from the domain, and then to see whether information technology can help the domain to become better, to make better decisions, to have a higher quality of the organization. So it is the primary goal of our research there is non-trivial application of existing methods, AI methods, to novel domains in order to derive new insights and give better guidance, especially to decision makers. This here is, I think, a pretty nice picture that brings that together. What I just said, let me see whether I can properly write that. Yeah, so you have here computer science, which looks at that more from an algorithmic side. Machine learning is part of computer science and statistical learning. Yeah, I take that as an umbrella term. You could also say, okay, here AI is the superclass of machine learning. There is a long discussion about the difference between machine learning and artificial intelligence. Very strong and interesting, and in the meantime, political discussion. And then you have here the area of domain sciences, be it healthcare, for instance. Yeah, take healthcare and decision-making in healthcare. Coronavirus tells us how important that is. And here you have an area where you say, okay, this is a region where domains are supported already by information technologies. And what we are interested in is in particular this region here, where we say, okay, is machine learning and artificial intelligence in general able to bring up some capabilities that allows us to better understand the domains and to make better decisions in the domains? Yeah, and that's an open question. It's not an easy answer that you can say yes, because deep learning is so great, and that's the reason why it will bring something to the table. It is not so clear in the first place. You have to prove that it is essentially novel, brings novel insights, and makes novel contributions. You have to prove that, and this is exactly where we do research. Oh, let's skip that table. To motivate, because I know, I assume that a lot of people in this room here at HPI are having a computer science background. In computer science background, the domain theories are not always very important. Yeah, this is more, I mean, I studied computer science myself. For us in multimodal systems, the domain, at that time it was from industrial design, what we worked on, or newspaper and media design, that was only background noise. That gave us some information, but we focused on developing systems. So therefore, looking into domain theories is something that is not intrinsic in all regards to computer science research, while it is in information systems. And here I have an example, a very complex one, string theory from physics, and I looked for a nice visualization that gives you some formulas and also some pictures, and you see that one of the most complex theories that physics has to offer right now in the standard model, yeah, you see, okay, there are mathematical relationships, mathematical proofs that relates entities with one another, causal effects and so on, but they also have visualizations in their theories in order to make it accessible and so on and so forth. And then we have Higgs boson, the God particle that tells us something about matter. Yeah, what's the difference between matter and photons? Yeah, and what can travel with light speed, and where is inertia coming from in material? And then with this theory that was actually developed somewhere in the 60s, yeah, with the Higgs field and Higgs boson as a special part of that. Then you have the theory, and the physicists know very well we need to test that kind of theory. Yeah, so the domain is given by the physical environment of the world. They have a theory about this domain, and now they want to test that. And the interesting part is that what they did is they were very early in processing big data, extremely big data. Yeah, for instance, the Atlas project that was part of the Higgs boson investigation in order to identify that there is a Higgs boson. They had, here are the numbers, 6 million megabyte per second. Yeah, 60 million megabyte per second. No system on Earth can at the moment process so much data in 1 second. So they introduce a trigger mechanism to reduce it and so on and so forth. But to compare it, yeah, you see 5,400 4K video streams at the same time. Yeah, I mean, it's enormous amount of money with a lot of data centers. But the important thing here is that the physicists use the theory as the starting point, make some hypothesis, and then go to the big data analytics side with a Large Hadron Collider. You see here, yeah, this is where the collision is, and you see all the particles coming out, and they are traced. 99% of the objects are discarded, yeah, and you are only tracing the most important objects. Yeah, this is done with big data, and if you have that, you report back on theory. In my understanding, and I'm not a physicist, I'm working with theoretical physicists in the quantum computing field, but not in high energy particle physics, even though people in my team are from that area, they know more about that than I do. But as far as I understand, these experiments on the data analytics level reported back insights to the theory. In this case, they proved that the Higgs boson actually exists. Okay, and this is actually the paper I'm going to talk about in the next coming minutes. Are there any questions? Okay. Good. So I hope that it was motivation enough for why theory is important. I mean, natural scientists naturally say, okay, we need a theory that can be proven in reality, and we learn from the experiments. We go back to theory in order to prove that. Yeah, they even have the two, in physics, they have the two areas where you have theoretical physics and you have experimental physics. And they do that back and forth. So for physics, it's quite natural. Now let's talk about what happens in information systems theory, and what we borrowed from is a lot from psychology and sociology. And psychology and sociology have borrowed a lot from physics, from natural sciences. Why did they do that? Because they said, look, when Wilhelm Wundt in 1871 founded or brought up the idea of psychology, they had a hard time to explain why this is science. And then they tried to get as close as possible to natural sciences, yeah, and that's the reason why they also adopted the scientific method of physics and chemistry and biology and incorporated that into psychology and sociology, at least in certain areas of these faculties. Okay, so this idea that theory is important comes from various areas and is adopted by information systems. And the basic fundamental elements is that you always have certain kind of abstract constructs and you have relationships between them. Yeah, and these relationships, if you talk about natural sciences, are often causal relationships, but sometimes they are also ontological relationships that you would say is a subclass of. Yeah. Okay, so you have a certain kind of theoretical understanding of your domain that you want to investigate. And that with the first thing, I mean, you are all senior in your studies, yeah, so you know that it is important to have a research gap. At the beginning, you look into your theory, you see, okay, there is an area where we don't have much knowledge about. We derive research questions from this area that might help to extend the theory or to fill holes that we see. And then you translate that into some hypothesis. This is where HCI nowadays also is very clear. If you want to publish on Chi conference, you have to follow that path as well. Then you design studies to minimize confounding effects. That's the reason why you end up quite often in laboratory studies on one hand side, or some areas which we also use, but they have some, yeah, let's say they are not so easy to qualify scientifically if you run mechanical Turk experiments or online experiments where you don't know exactly who the subjects are. Okay, there are some measures how to minimize your risk that the robot is sitting there or that people are only pressing 3, 3, 3, always the same number or the same rating. Okay, then you collect the data by these experiments and then you draw inferences. And these inferences help you to give an insight back on the theoretical level. Yeah, so you have a domain theory, you make domain-driven research, and it relates back to, it makes a contribution, and this is what we call insight. Okay. Now we move to data-driven research, and this is really interesting, yeah, because this idea of data-driven research, which makes a contribution, is something that goes beyond simply going on Kaggle, getting a data set, and then you are happy if your Python library does, or your TensorFlow and PyTorch library works properly, and you get a certain kind of accuracy at the end. The question is, what did you learn? What is the insight? Yeah, and then if you come to that point, yeah, that it is not only fascinating that it is working, but the question is, well, how it contributes to theory is when you look into data-driven research. And I have here from two authors, Jagadish and Shmuelian Kopius, some ideas on the steps similar to what we have seen before, how to conduct data-driven research. So also here, what the authors suggest is to start with a research question, also based on the knowledge gap. Yeah, so something has to drive your research. Otherwise, it's just toying around or learning about the technologies. No, you start with a research question, but then in contrast to the, let's say, empirical approach, you start thinking about the sources of data that are important in order to investigate the phenomenon in the domain. Then you go into data engineering with data cleaning, extracting, annotating data. You do feature engineering, all these techniques that you know from data analytics, integrating, aggregating, representing data. Sometimes the people here from industry talk about smart data, data that has a higher signal. It is a stronger signal for that is better supporting your investigation. You discard certain kind of features. You have cleaned the data. You have normalized the data. So that it really fits also to your models that you deploy in the next phase, where you do analyzing, modeling in order to find in particular correlations, but in general patterns. Something can be found in the data that is of interest, and then you start interpreting the patterns. And if you have the right theoretical perspective of that, the patterns can be turned into insights. The interesting thing is, and I only mentioned that, we can have that in the discussion. Interesting question is, what is the right data? Because if you start thinking about the data, you start already thinking about the domain. No data that you collect is domain independent. If you collect temperature, you already bring in a knowledge nugget. It's a little piece of knowledge that you investigate. If you have temperature, you discard maybe humidity. Why did you do that? You need an explanation why exactly this feature is of interest. And you have to report on that. And then you have to also report on the representation of the data. What is the sampling rate with which the data is collected? What is the sensor by which you have collected the data? A friend of mine from MD Anderson makes a scientific living by proving or by analyzing the data collection in bioinformatics in top journals. And it takes him usually half a year to 1 year to really investigate bits and pieces of the data collection, data engineering, and data processing tasks. And he never found a single paper in the top journals of bioinformatics that hasn't had a flaw. Not one single paper. And one interesting piece of evidence that he found was in one highly cited paper, he found that the signal was not caused by the underlying phenomenon, but it was caused by the machine that collected the data. And that is something where science has to start all over again. So thinking about the data, thinking about collecting and annotating data is absolutely crucial and really difficult. Extremely difficult to make that scientifically on a very good level. Good. So now we put together all these elements. We have on one hand side, we have the stream that I said at the beginning, the data-driven approach, and then we have here the theory-driven approach, driven by domain theory, while on the left-hand side it's driven by the data. I mean, if I investigate, as I try to motivate based on previous research, also big data has to start somewhere. It's not arbitrarily where the data comes from, but you have a certain idea that this data can help you in order to make a contribution to a certain phenomenon or explaining a certain phenomenon. Yeah, so big data is not theory free, if you perceive that from a data-driven research point of view. But it is not as pressing and not as, let's say, big as it is on the right side when you start from a theoretical, theory-driven approach. Yeah. So the question is, how can we bring together those fields? You have on one hand side, you have all this big data and data analytics, yeah, and the people come up and say, yes, we can do everything and we investigate everything. And on the other hand side, you have the people who know very well about the domain theory and about the relationship between information technologies, standard information technologies and the theories, you know that very well. And now how to bring that together. Yeah. What you often see is, and this is not special for information systems, is that when you have this theory-driven research, as I described, that the data here is comparably small, while here we have big data. We have big data sets. That is an interesting development. Yeah, I mean, on the right-hand side, yesterday I attended a PhD defense at the Max Planck Institute here in computer science, and they did work on was published at WWW, a World Wide Web Conference and so on. But here, this is more here in this area where they had 20 subjects in one case and 50 subjects on the other case, and did some very good research on explainable AI. But the data that they use is rather small. While on the other hand side, if you have Twitter data, or if you have Facebook data or some other data, if you go into manufacturing, or as we do in quantum computing, you are drowned in data. And the question is, how can we make a contribution to theory? Okay. Yeah, mapping big data analytics, and this is from left to right. I go back. We go this path, as you will see in a slide that is coming, but we first go from left to right, and then we go from right to left. Okay, and then we try to merge that. Big data analytics to domain theory. What big data can help us, and data analytics underneath, can help us to explicate patterns that can be interpreted and explained so that we can get some new scientific insights. And in order to do that, you have to carefully analyze those kind of patterns. And if you have made those kind of patterns explicit and clearly describe the pattern, you can help to develop, support, refute, refine constructs from the underlying theory. Okay, this is the example that I've given you from the physics side. This is natural for them. But if you think about HCI research, multimodal research, explicating patterns and thinking what that means for the theory of human behavior while interacting with systems, maybe it's not so clear cut, but that's an opportunity for developing, with the help of big data, to developing, let's say, initial theories to grow them into some mid-level theories. Okay. Yeah, an example here, first example that I have is from healthcare. A very simple example where you can use a support vector machine approach from a statistical learning approach, where you have two different classes. This is from cancer research, and you are able to separate. Here you see that tumor volume and the number of some feature you have to see, metastasis, how wide it's spread. These two features were already helpful for distinguishing two classes. So that's a real interesting insight. And the question is that 100%, as it is visible in this case, is 100%, or you have different kind of outliers? Yeah, they go beyond the boundaries. Yeah, you want to know that. How good is this pattern? Yeah, so what you learn is if I take this feature here and I take this feature here, with this data, depending on the way how you collect that, you can make, in this example, 100% differentiation between class A and class B. Okay, that's really really interesting. When we did that for the World Anti-Doping Agency, we did that for sample swapping, yeah, whether some athlete has used urine from another athlete that was clean in order to cover up. The initial idea of the biochemists was, no, you will never find a method that can do that properly on a high level of specificity and sensitivity. And then we went back to the drawing board, used big data analytics methods in order to find a pattern. In our case, we use PCA in order to reduce the huge number of features. You know, it was not so easy like in this case. But then we found a pattern and brought that back to the experts, and they were surprised. And then you start thinking about what that means for theory. But it's not always going right. Yeah, here is an example, the famous Google flu trend. That was even published, I think, this paper here in 2014 in Science, which showed that in some cases, you don't have enough knowledge extracted, so that in this case the prediction of GFT was overshooting, yeah, twice as overshooting. You see here that the actual number of flus at CDC, the Central Disease Control Organization in the US, found out that here Google was overshooting 2 times, yeah, far too high. And if you would have trusted that pattern that was extracted from data purely, you would have made decisions. You would have installed prepared hospitals for something that was predicted, but what is actually not happening. So in this case, big data analytics showed that you have to be very careful that the patterns that you find are really happening in the domain. Yeah, so real patterns, and to scrutinize that a pattern is real is something that takes a lot of work, a lot of evaluation in order to prove in the domain that you really found something that makes a contribution to theory, and then in the next step to decision making. Okay, yeah, contribution to theory is to support abstracting beyond a particular context to more general concepts. Yeah, so you don't want to have it on the instance level, you want to generalize. Good. Yeah, here's an overview that we have in the paper to make that a little bit more tangible, because when you talk about big data and so on, you can easily drown in formulas, and we try to make that a little bit more tangible, to say, okay, if we go here from left to right, you have certain kind of data dimensions. You have, if you in particular think about supervised learning, you have independent and you have dependent data features. And data features is nothing else than attributes, yeah, in tables and relational tables. Features is mainly from the fact that it's influenced by visual computing with the features, but in the end, these are data columns or data attributes that you have, and you have dependent and independent. And if you have unsupervised learning, you don't have the dependent data features right away. You don't have labels. Yeah, and then you can push that into supervised learning models or in unsupervised learning models, explicate the patterns, yeah, explicate the patterns. And what you are in particular interested in is what are the concepts and relations. Funny side note, or a side note to that, knowledge graphs. Knowledge graphs are usually on the instance level. And if you, at least in our experiments where we run, on the instance level triples that you have between entities, and you find certain kind of relations. Most of the relations are useless. Why are they useless? Because they are contradicting domain theory, and there are good reasons to say that certain kind of relations in knowledge graphs don't exist because they don't make sense. Yeah, and this sense making is then not done on the explicit pattern level, but it's done on the domain theory level. Yeah, and therefore the embedding of the patterns in the domain theory is very important. And at least so far, independent of the causal discussion that we see in machine learning, it is not solved to do that automatically. Yeah, because to have insights in a domain, to have a deep understanding of the domain, is not something that is part of those kind of patterns. However, I see colleagues like Andrew Ang who would most likely argue we are not there yet, but we will get there. Yeah, let's see where research is heading towards in the future. Okay, going the other way around, domain theory to big data analytics, also very interesting and very important. The theories, as I said, express abstract concepts and relationships. And theories are used to derive hypotheses. And these hypotheses, following Popper, are used in order to falsify theories. And as long as a theory is not falsified, you can go on with hypothesis testing. But in the collaboration with data analytics and big data research, these hypotheses can help us to ask questions that are handed over to the data analytic research side in order to investigate the hypothesis on the data level. Okay, so domain theory can guide the search for patterns by identifying possible constructs and relationships that can be used in the analysis. Okay, so it gives an idea on what kind of data is important and interesting and guides data analytics. So domain testing using big data is much more complex, because it adds additional challenges. Yeah, you have to find the right scope, you find the right sources for your data, and then you have to see that the data quality is on a good level. As a side remark, in our research, what we realize is to really get data of high quality, or that can be turned into data of high quality, is extremely challenging. Yeah, you have to beg a lot so that organizations or companies provide you with data. Creating data is expensive and requires a lot of experience, and so therefore the theory helps you to get the focus right, so that you don't collect data that you don't need in order to answer the hypothesis. Okay, so domain theories may suggest new data sources that haven't been considered by data analysts so far, and they might also, based on theoretical understanding, they might also derive and suggest novel combinations of data sources that have been analyzed by data analysts so far separately. Good, so that goes the other way around. I'll make that quickly. We have the domain theory with the constructs and relations. We derive hypotheses. We conceptualize that. That's what is called in social sciences and information systems instruments. And these instruments are then mapped on the data dimensions. And in particular on the model level, and these models are then tested with the help of certain kind of data sources. Yeah, what we don't have in this case here is immediately a feedback loop, but you can imagine that This here is, there are several circles, iterations, iterations going on till you finally have a result on analyzing big data guided by domain theories. Good. So putting that together, we found out that at least for information systems knowledge, I mean, if you have here healthcare as an important domain in information system research, and here you have data analytics and data-driven research. The question is, what is the role of IS? And in order to investigate decision-making with the help of information technologies, you want to compile all that kind of knowledge somewhere in the middle. It is not healthcare knowledge, because the people in medicine and biology have very deep knowledge about cell structures, about cancer and all these kind of things. The people on the data analytics with computer science and statistics and so on, they have deep analytical mathematical knowledge and formalizing systems, and developing also particular IT systems. But bringing that together, if you want to run a hospital, for instance, or a practitioner, if you want to support nurses, you cannot ask the left side and you cannot ask the right side alone, because they are specialized in other areas. But usually they come to people like us and they say, let's design a system and services that help us to support a surgeon in the surgery room, to help vaccination systems, vaccination organizations. They need services based on big data and on theory, and therefore you compile the decision-making knowledge in the middle of information systems knowledge. Good, so there we identified several challenges, how to work that, bring that together. The first challenge is reconciling competing approaches to create and refine domain theories using big data. So they have a proper understanding of what they do in their research. They have a proper understanding, and the question is, how can you bring those people together with DeepMind? I mean, it's a very nice example with what I will talk about in a minute about protein folding. They learned how important it is to work together with biologists. But this is foundational research. This is natural science-driven research. What they are not doing is research on a decision-making level. So if we move up at this area, it is a question how we bring the left side and the right side together so that they can properly collaborate. That's challenge number one. Here is an example that makes it a little bit more explicit. Here on the right side, we have a theory that is actually stemming from our research on anti-doping. You see here the metabolism with testosterone, EPO, which you're using for enhancing your blood capacity and the capacity to store and process oxygen, bring that to your cells and to your muscle cells to have more power. And what theory is telling us on the right-hand side is here you have constructs and you have certain kind of relationships. And especially for biologists, these are pathways. Pathways means this is how the biochemistry flows over time, how they interact over time. And then on the other hand side, you have big data, or you have data. It's not always large amounts of data, but you have a lot of data. And the question is how to bring that together. And on the left-hand side, you have clear theoretical understanding of how to deal with the data. And on the right-hand side, the biochemical theory has biological information about pathways and all these kind of things that are deeply rooted in biology. Okay, and bringing the more technical big data analytical side together with the biochemical theory takes decades in order to come up with an integrated view on research. If you have that, and in particular for anti-doping, there are only a few sites in the world, like in Cologne we are working with, and in Copenhagen, and these are sites where these understandings, different theoretical understandings, flow together. Actually, my group is contributing here from on this side in order to support people that use the theoretical analysis, but they also use standard statistical knowledge, standard statistical theory, how to treat data. And now the question is how AI comes in. And the funny thing is, or interesting thing for us, is that we make a difference. And we didn't know before whether we can make a difference or whether the theory that was used on the data and statistical side is not already good enough. And what we found out is that AI is contributing to the knowledge on the theoretical level on the data side. And this is now bringing back knowledge on the biochemical theory side as well. So the resolution for the problem, the challenge number one is very simple. In one respect, you might think is that you help to merge the theoretical attentions between the data analytics side and the domain theoretical side is the means there that sometimes helps is abstraction and generalization. Yeah, abstraction is hiding noise. Yeah, you abstract from very specific analysis of the data. And then you abstract, and generalization is a question of constructs in the context of ontologies. That's on the right side where you have the theoretical knowledge, where you move up the ontological understanding. You're not talking about cats, you're talking about animals. That would be a generalization path. These are two standard methods that helps you to merge these theoretical views into one homogeneous view. Okay, I think I skipped the IS view and come to challenge number 2. That goes from domain theory and then you go to big data, so the other way around. Selecting data analytic techniques to conduct theory testing. So the challenge is how to find the right data and the right techniques that fit to the requirements of the theory testing. Well, so the healthcare people have a certain kind of idea that they would like to investigate. Yeah, does a third vaccination help and is accepted by the people? And what is the role of the Corona warning app in this regard? Does it help? Does it reduce stress or whatever? And then you want to ask the right questions. You want to find the right data. How does it work? Yeah, so this is a challenge. And here you see right away 2 examples on the right side. And I took an example from spatial cognition. And in the 80s and 90s, I did my PhD in this area when I worked with multimodal system. I wanted to understand how you navigate in space, and then you get information about gestures, about speech and object recognition to get that together. And you easily come then to the conclusion that you have to understand something about cognitive maps because you want to support the human being in a certain way. In the 80s and 90s and also in the 2000s, that was challenging to collect data. So we were working with small data sets, like in a highly cited paper here from '89, and still very interesting to look at. These are very few data points, and it is more like a toy environment. But now with big data and new approaches, we open up a new space how to investigate the theory of cognitive maps and spatial knowledge in general. And here is a very nice example here from Board 21, just recently, a very fresh paper that shows how you could ask Uber drivers about their cognitive maps of a certain region. Please draw a map. Yeah, I mean, you have knowledge about that. Yeah, and you could also even go beyond that and say, okay, maybe I have a natural language interface, and I ask these people from once in a while, do you know what is in which region you are, how it is connected? Is that a new region, a different region? Do you think that is separated? Have you ever been here? What do you think? Is it north or south of a certain other region? Yeah, so this might be a way to investigate how people navigate in space, and that is extremely much better than everything that we could possibly do 10 years ago. So it opens up a new field, and now the theory tells the researcher or collecting data, for instance, by using Uber, to ask the right questions and to look for the right data, and maybe also to give some requirements on the models to be deployed. Good. Third challenge is, it flows from left to right into the middle. Solve problems that are unsolvable from a single perspective. Yeah, so there are some problems, or hopefully there is. We make the hypothesis there is, and it gives some examples for that. That you say, okay, this problem that you have cannot be solved by big data alone, and it cannot be solved by domain theory alone. But you have to find a way how to bring that together with our focus on decision making in particular, yeah, where you bring that together, where the data analytic path is not enough and the purely theoretical path is not enough. COVID-19 might be a very good example where information systems knowledge, how people use information technologies, might be a good starting point for doing research, bringing together these fields that would otherwise stay alone. I mean, Corona is so much hyped up at the moment. There is no possibility to get funding for a project to investigate the Corona warning app. But that would be a natural point, because the data analytics of what you collect with the Corona app is not going anywhere. Otherwise, we would have much better services. Okay, so the data is collected and the analytics is done, but they get lost in the data and they don't know what to do with that. On the other hand side, the domain theorists in virology and epidemiology, they have their theories how viruses spread in geographic regions. They have their theoretical models, they inject certain kind of data, but they have no idea how people actually behave. They don't know how people make decisions with respect to boosting, with respect to vaccination, and all these kind of things. This is beyond domain theory of epidemiology, and this is beyond the theory of big data. So this is exactly the point where we bring together and where we see a possibility to overcome these barriers with the help of information systems knowledge in the middle. Yeah, I already said AlphaFold as a tangible result where you can slightly understand what is actually happening. I don't know whether you're aware of the protein folding problem. The problem is that if a cell is produced, you have a long string, and the folding of the cell tells the system what type of cell it actually is. Okay, so, and making a prediction with a certain kind of lengthy structure, what kind of cell by folding is actually produced, is important to understand the biology of life in general. And the complexity is so high that they said that a lot of researchers, and it was common accepted knowledge, on a theoretical side, that there will never be a mechanism that makes a prediction from a sequential string to a folded structure that actually is the cell. Okay, and AlphaFold from DeepMind in strong collaboration with biological institutions, they found a way based on machine learning in order to have a high accuracy in predicting the outcome of the folding process. Yeah, and this is interesting for biologists because they didn't believe that this is happening. Yeah, that this is even possible to do that. And now you can try to dissect the mechanisms important for folding processes, yeah, and going deeper and deeper in this kind of understanding. This is on a natural science level. The example I have given you on the COVID level, where you have the Corona One app, is more on the information systems level, where you want to make a decision what kind of information should be given to a person, so that this person has the right information as he or she wants in order to be informed about the vaccination, in order to increase trust and reduce anxiety. That would be where you have here on the natural science level, you go up the ladder. Another example, this here is the architecture. The architecture of AlphaFolding. There are interesting embeddings or the theory that were important and crucial for the success of protein folding. Yeah, for AlphaFold. Yeah, and but I think I don't have time to go there into all the details. Okay, and then the other way around, yeah, if the arrows go in, we thought, okay, the arrows might also go out. Challenge, sharing data and models across research teams. That means to also inform other fields what was found. Yeah, and this is to make the all permutation complete. And I only want to talk here about the example. So the GPT-3 model, which is one of the most sophisticated natural language processing models. Now they're working on GPT-4, and also Google has a natural language system which is extremely large. GPT-3 was developed by OpenAI, a joint research institution funded by Tesla and Microsoft in particular. I think there are also some venture capitalists involved, and they developed this kind of GPT-3 model. And what they did is to say, okay, we have solved certain aspects of natural language processing, but now people use it in order to apply it in different areas. So it reaches out to theories or to developing or improving theories in other domains. And that's the reason why open source software development then is very important, so that people can use it and come with their own visions, their own research questions, and say, okay, is that a tool that might help me in order to answer those kind of questions? Another example, what I like very much is the first Google Translate system. I think that was published in end of 2016, but the more higher quality publication was in 2017, where you see that the same here is the same sentence, the same logic of the sentence, and the threads here between the dots, they are a certain region in a vector space where you embed language and words and sentences in a higher dimensional vector space similar to a PCA structure. And if you look into it, you see that for the same meaning, you see that the languages are separated. And the question is, what does it mean? What does it mean that for the same sentence with the same meaning, that in the vector space representation, you can clearly identify boundaries between languages? So the question I foresee is, what does it mean for computer linguistic theory and maybe for linguistic theory in general? So far as I know, this is an open question, what that vector space embedding and outer encoder kind of systems actually mean for the theory of understanding language. Okay, here it is a little bit about a summary about the challenges that I talked about. The role of IS, I don't want to overemphasize the role of IS. I mean, it's important for my research and my group's research, but I think that the paper is not only targeting IS alone, but it makes a contribution also to other areas, but due to our background, we were looking into IIS in particular. Okay, with this, I come to an end and I would be happy to answer any questions that you have. Thank you very much for your attendance.
So, thanks, Professor Maass. Questions from the audience would be welcome also. We hope you're still with us. Can we just quickly get up? And just stretch a bit. Just do some turn taking in our minds. Yeah, there's no goal for this exercise. It's just, I want to see how flexible you are, that's it. Yeah, because if we're going to be doing bridging research.
Yeah, very good.
we need some more flexibility and yeah, a bit of, yeah, intermediary roles, proactive roles. Thank you very much for the style and the tone and the way you extracted all the things about that paper. Please, you can sit down. Thanks. We have 25 minutes for discussion. 20 minutes. There was a lot in the slides that I really also, it just brought me a lot of joy seeing the examples in color now. But the goal is to take that in and try to reflect also on this board, maybe in our reflection session. If you have questions for him, you can directly ask. But let's just do that. Let's just really maximize every slide that you saw and reflect on that. And we would always also be in touch with him, and I'm happy to follow up with that. So questions. I think Wim was first, but.
Yeah, thank you very much. I think it's good to have a talk like this, reflecting also more on the more philosophy of science kind of ideas. But I was wondering, how do you define big data? I haven't seen a definition really. So what is big data for you?
What is big data? I mean, there's the standard answer is the 4 V's, yeah, where you have variety, velocity, veracity, and volume that you have. I mean, big data as a term is a moving target. What we call big data nowadays will be small data in the future. So it's more the question is, or it's more metaphorically understood. So far in research, in many research areas, we confined ourselves to rather small data sets. Yeah, because it was difficult to get access to data. I mean, it's not easy nowadays either, but it was beyond reach, for instance, to think about Facebook data or Uber data or any kind of other large data sets. Yeah, if you go to a manufacturing site, yeah, we work with large manufacturers. Now they have sensor technologies and so on. Yeah, what did you do when you did manufacturing research 10 years ago? You had to set up everything in your little tiny environment. You try to extract the data, but you had no way to investigate what is happening in reality. But now with RFID and sensor technologies, social media and so on, you are overwhelmed with a lot of data. Yeah, and this turns around the whole thing. And I think it is more the attitude that is changed with big data, that you say, wow, data is not only let's say an unimportant side effect, yeah, as it used to be, but it is a main driver for our research. So the way how we think about data-driven research is different from the time, especially when I think about artificial intelligence. In the 80s and 90s, we were more thinking about rule-based systems and ontological systems and all this, and the ontology was a crucial part. And then you said, aha, that's a T box, that is really important, but the A box, yeah, you have always the elephant. You always have the elephant, and you always have the toy examples. But now it turns around and you say, oh, I have access to the real world. I have access to the real world, and it comes in a deluge of data. And now the question is, oh, how can I cope with that? And then it also has requirements on my theoretical understanding, because my toy understanding of these small data sets are not sufficient anymore. So data is pushing us, and that's, I think, is a crucial element of big data, to understand that we have access to the real world.
Yeah, okay, thank you. May I follow up on that?
Yes, yes.
So I feel like in social sciences, if we think about big data, the very term is confusing, because often it is lightweight data, unimodal, collected in a way that you cannot contextualize anymore, but you can answer like big questions. But it's almost like a Heisenberg principle. You can measure the speed, but not the position. And it's the same with big data. If you really have questions that you answer in big data, these are different kind of questions that you could ask by looking at the data, doing some quantitative analysis, but that you can still contextualize given the larger space of information that you have. And I feel like going to the one domain and to the other, there's not just one theory that you're testing, you're actually shifting your attention in some way, or it's almost incommensurable, it's almost like a paradigm shift. I feel, in your talk, I felt like you're almost taking a physics perspective, but I wonder whether it can be applied to, for example, social sciences. Because in my experience, big data there is not really, it has volume, but other than that, it doesn't have.
What was the last sentence? I couldn't get it.
Well, for social sciences, I'm not too impressed yet by big data, and also I don't have the feeling that they're in any way more real. As you are saying, but I'm just saying it as a discussion point.
Yeah, I think I would like to prime us towards thinking in the sense about what all these questions and challenges could mean for our context of the Envision video, or many other types of data that would still help us understand insights about gestures and affect. So I know it might not 4 terabytes of video, depends on who you ask. It might be overwhelming to one researcher and it looks very, very big, but in some other contexts, some people are analyzing the whole of YouTube and it goes on that scale. So we could just try, but yeah, good, very good. Yeah, I don't know if you want to follow.
Maybe let's have a comment on that. Big data, at least in my understanding, is not only, or is not if you have high resolution pictures of a single person. Yeah, and you have hand gestures of just one person, and you have that. I mean, you have 4K and you might have 5K and even more. The data explodes. But this is the data that is not helping you much. Yeah, this is not data, it is big, but it's not qualified as something that helps you to do data-driven research. Yeah, so the size alone doesn't qualify as something that is helpful for data-driven research, improving the theoretical understanding on the other side. It would be it would be most likely more interesting to have lower scale pictures of very many people acting somewhere, because then you can derive cultural differences, you can have gender differences and all these kind of differences that you don't have if you have a high quality resolution of just one hand. Yeah, and my colleagues in computer science, very good people in visual computing, they analyze one person moving in a green room and trying to extract a 3D model from that particular person. A person who looks at that from a domain perspective would say, do you have data for, let's say, a city or a large society that we can understand the posture or the back problems of the people or the behavior or changes over decades or whatever? Then it would become interesting, and then we start about big data that is helpful for data-driven research. I don't know whether this expresses properly what I tried to say, but yeah.
Thank you very much.
Thank you. I thank you very much. That was a wonderful talk and incredibly articulate about many of the issues that I think we're all thinking about and we've been considering. I think in the case of what we're doing here, not only is it multimodal, but it's multidisciplinary. So it adds new factors. We're not just dealing with one theory domain or domain theory, we're dealing with N domain theory. And we've experienced this already just looking at little snippets. When people are talking about, from a phonetics point of view, it's interesting to think about these things. From a gesture point of view, it's this. From a design theory methodology, it's this. From linguistics, from a et cetera, et cetera, et cetera. And then what gets complicated there is not only do we have lots of points of view, but we have the chance to share our theoretical frameworks. We have a chance to share the implications that we learn from each other in these new applications, and then we get to communicate it at large. And when I was looking at some of your presentation, I was wondering, gee, how do you do that well? How do you get that information back into the community so it makes impact? So there are several things in there, and please feel free to comment whichever part you like.
Yeah, I can only support your view, yeah, that this is, I would say, an extremely, let's say, positive kind of situation that we are in. We can ask questions we couldn't ask 20 years ago. Yeah, so this is an open field where interdisciplinary work can make a jump forward, a huge jump forward. What I mean, look, I'm working in healthcare. I'm working with mechanical engineers. I'm working with anti-doping, which is very special, with governmental agencies and so on and so forth. Yeah, so a lot of different kind of disciplines. And what I learned is always to first understand the theories or the basic theories that the people bring to the table, because otherwise we cannot share knowledge. We cannot collaborate. Now, with the help of a data analytic approach, I can ask my colleague, what is the data that you are looking at and answering your questions? Yeah, what is the data that you are looking at? Then I can ask another person who looks, let's say, from an engineering perspective on the same problem that we are looking at. And he or she will say, no, we are looking at the dynamics. We have the dynamic system. Yeah, we are currently working on simulation of physical objects if there is a force coming on it. And then we learn that the dynamic modeling of all this with FEMs, a finite element method, is very important. And this brings in a completely new perspective on the modeling and the data that is necessary in order to support that modeling. Okay. So sitting together there, a physicist, a theoretical physicist group, a computer scientist, business informatics, engineering, and everybody brings different views on the data to the table and tells with the data what they do with the data. And the interesting thing is at the moment is that a lot of disciplines see value in statistical learning and machine learning in order to answer their questions. So machine learning at the moment is something like a bridge building entity. And this is really fascinating. This is really fascinating that we build a certain kind of common language how to deal with data. And then from data, you can get to insights, to patterns, and from there to theory. Yeah, and then you start merging the theories because you agree on the data, on the way how to analyze that, and then knowledge starts to flow. So I think this is one of the most fascinating phases of my career, that we have these kind of tools at our fingertips right at the moment and the way how to deal with that.
Thank you.
Okay. Online, do we have questions online?
Not yet.
Not yet. Comments, questions, a slide you want to see again?
There's a yellow hand.
Julia has a hand. Yeah, Julia definitely has a hand. Yeah.
Julia, you can unmute yourself and ask.
Oh, you haven't seen it.
Yeah, sorry. Yeah, no, I mean, my question is also, I think, associated with social science in general. Because I think the problem is, I mean, I really like this idea of data-driven because, but the problem is, I think that we have problem of classification sometimes in social science. Sometimes we are, because it's not object that we can really see from external point of view. And so sometimes you don't know exactly if, for example, using data-driven research, it's a risk of overfitting to a specific definition of a psychological concept, let's say. So I think, I mean, in social science, at least we need at least to agree what we are looking for first. Otherwise, I think there is a risk that, I mean, especially, I mean, right now there is a lot of controversy, especially in machine learning and computer vision, in a sense that it's also used on data sets that are biased, for example. So there is also this question of where the data came from, and sometimes when you collect the data, obviously you miss some data. I mean, you're biased when you collect your data, and so I was just wondering. I think it's more like yeah, I don't know, theoretical challenge to try to understand exactly what we are looking for. So I don't know if you have any. I mean, and I think social science, unfortunately, is in trouble because of that.
I mean, you're absolutely right. I hope I made that clear that data quality is a crucial issue. Yeah, and I see very often results published and communicated based on very dubious kind of data sets. Yeah, where and they also don't give enough information about the data sets. I think from our research community, when I'm a reviewer of our top journals, I'm always asking for the data set and the models by which the data is processed. And I never get it. I never get it. So I think the problem is for research that we almost have no chance in qualifying and replicating results that are presented by other researchers. And this is what we have to overcome, what we definitely have to overcome. I mean, in the UK, as far as I see, you are from the UK, you already have a strong emphasis on and importance on the importance of secure data havens, where you securely can store data. Yeah, I think almost all leading universities in the UK have that. In the rest of Europe, it is more a dire situation. Yeah, we are not sharing data. But, we need to scrutinize data as we do it with papers. And we need to really change the way how we evaluate scientific results based on data. With the current way, nobody has a possibility to really assess the quality of certain kind of research. The only thing is what you can do is to try to collect the data by yourself and then to try to replicate And in many cases where I tried that myself, I failed to replicate the same level of quality. Yeah, so this needs to be changed on the scientific level. But this also, you said bias, sure. I mean, Amazon deleted or abandoned their HR selection system based on data that had a priority for white people and rejected black people. Yeah, so these biases are really important. I would say, I mean, we are just at the beginning of understanding how to deal with that. And that was the initial driver for our paper, to say, look, we don't have answers. We have challenges and we have ideas how we could overcome these challenges. But there is a lot of research needed in order to get the operational levels of data cleaning, data quality, method selection, and all this quality measures of the results and so on and so forth. Yeah, we have a different paper on DKE where we try to bridge, for instance, conceptual modeling as a help for machine learning modeling. Yeah, these are little tiny bricks. Yeah, and your last point was on, is that a threat for sociology? I would say no, just contrary. It opens the door. It opens the door to better understand, not only to sample people, but to get closer to a whole population. Yeah, by obeying GDPR if it comes to individual people, yeah, for sure. Yeah, I think GDPR is good and helps us to have a clearer understanding of what data should be could be leveraged and what not, and what the legal perspective of all this. But I think if we obey GDPR and future changes to GDPR, this opens up a unique opportunity to better understand what's going on. Yeah. I mean, in business administration, we have very simple models of buying decision behavior. Very simple. Yeah.
I don't know if I can just add a quick comment, because yeah, my point was also, I mean, I understand that, I mean, the data of the quality, I mean, the quality of the data are important, but at the same time, I don't think we can have I mean, there is always a problem of noise, and there is always some unknown variable, especially in human, I mean, in social science, that I don't think we can assess everything. So I think we just need to be aware of this limitation. But my fear is also in terms of categorization. Sometimes I think we also need to be aware of what exactly we are looking for. I mean, or we define our concept. Because, I mean, I don't know if it's the case in other domain, but at least in psychology, I mean, you have, I don't know how many different definitions for the same thing, but you're not sure if it's the same thing. And so obviously, if you apply different criteria to look for a phenomenon, I mean, if you define differently a phenomena, obviously, I mean, you will, yes, different things. I mean, so you cannot replicate if you don't apply the same definition. So my fear is it's also if we are only data driven and we don't inject some theory and also like start to really think what exactly are we measuring, I think we are running into trouble. And yeah.
Absolutely. But this is the whole idea of this paper, to say you need theory in order to do something useful with data. And you need data to improve theory. And this goes hand in hand. I mean, if I work with my second supervisor of my PhD was a psychologist. Yeah, so at least I got in touch with these research field. Highly interesting. I like that a lot. But if you ask me if I can assess psychological concepts, I have to read, I don't know, cognition and behavioral brain sciences or whatever kind of journal. And it takes me a long time to get a basic understanding of what the meaning of memory is, short-term memory or whatever. Yeah. Now now we are in a stage where we say, how do you measure that? What kind of data do you use? Yeah. Let's talk about that. How do you deal with that? Yeah. This is what I haven't had, this opportunity I haven't had during my PhD. Yeah, we only had certain kind of images and react times and primary experiments and all these kind of things. Yeah, but I never understood, I never had a chance to pin down exactly the definition of this and project that on data. And then I say, okay, let's think that from a perspective of a computer scientist, what that means and what is the modeling and all these kind of things. Yeah, I mean, that was J.R. Anderson when they had the SAW model, and that was fascinating because you could pin it down. You could exactly say, okay, this is a statement, this is a relationship, this is a model. I think that was a success of the SAW model and these kind of models because it pinned down exactly what that meant. Super complicated, but on the other hand side, yes, it was accessible. Yeah, and data makes that kind of discussion more tangible, I would say, but we are just at the beginning. We're just at the beginning of having that interdisciplinary interaction. Yeah.
Well, thanks.
So, thank you so much. I'll stay in touch. Thank you so much.
Thank you.
Thank you very much. If you have any questions, Mr. Oyele has my contact information. Please let me know. Yeah.